Ghodsi.
Hello, everyone. Super excited to be here. We actually have now online 75,000 people worldwide that are actually listening in to this live stream.
Lakehouse IQ is just like a dream to me, just because of all the capabilities it has.
Amazing to learn about the implementation of LLM models.
I like the direction which Databricks is going in, and we're looking forward to it.
Unity Catalog has been really important to us. Lakehouse Federation and monitoring, yeah, they make it even better.
Everybody's just geeking out and yeah, having fun with data.
It's not about educating yourself on what you're doing today. It's about where the world is going.
Please welcome to the stage, Director of Machine Learning, Brooke Wenig.
Good morning to everyone joining us here in person, and good morning, good afternoon, and good evening to those of you joining us here virtually. Now, I know it's early in the morning, but please make some noise if you're enjoying Data and AI Summit. Woo! That was so good, I'm not going to make you do that again. Data and AI Summit is truly the highlight event of the year. I love that it connects data teams from around the globe and truly builds a community. I first attended what was then known as Spark Summit in 2016. And a few years later, I was on this very stage demoing the latest features of Apache Spark 3.0. I'm thrilled to be here with all of you today. As a bit of housekeeping, the keynotes will run until 11 a.m. There are no scheduled breaks, but if you do need to get up, we ask that you be respectful of our presenters and those around you, and to do so in between sessions. Before we can get into the keynotes, I want to thank our partners. Without them, this event truly would not be possible. Please put your hands together to thank our partners. And I want to do a special shout out to Accenture, Avanade, AWS, Microsoft, and Prophecy. Please visit them in the expo hall after the keynotes. To kick off Data and AI Summit, we launched the So You Think You Can Hack hackathon. It focused on either building LLM-powered applications or leveraging Spark Connect. And we had both an in-person and a virtual track. And over 800 participants participated in this hackathon. So without further ado, I want to congratulate all of the finalists you see up on the slide here. In particular, I want to do a special shout out to the grand prize winners in each category. Schema Spy, who built a system to navigate database schemas with AI assistance. And in the virtual category, Data DM, who built a data assistant to help you load, transform, visualize your data, all without a single line of code, and they actually open sourced it. Please congratulate all the finalists that you see here. Now on to the keynotes. Our mission is to democratize data and AI. But that mission is not that of Databricks alone. It is a shared mission in the data and AI community. And our keynote lineup today reflects that shared mission. Only at Data and AI Summit will you hear from the creators of the hottest open source projects, visionary academics, and Silicon Valley legends. You will not want to leave the keynotes early. We will be closing the keynotes with a fireside chat with Ghodsi and Eric Schmidt, former CEO of Google. I hope you all are as excited as I am to be here today. Woo! As Ali mentioned in his keynote yesterday, technology innovations don't become revolutions until they're truly democratized. Marc Andreessen is no stranger to this. Through creating the Mosaic and Netscape web browsers, Marc truly democratized the internet. something that all of us rely on for our day-to-day lives. 12 years ago, he coined the term software is eating the world, and a few weeks ago, he published a bullish opinion on why he thinks AI will save the world. Without further ado, please join me in welcoming Marc Andreessen and Ali Ghodsi to the stage.
Awesome. Thanks so much, Marc. Thanks for doing this.
Good
Really
morning.
excited.
Good morning, everybody.
Can we get a hands up for those of you who've read his essay on why AI is saving the world? All right. Yeah, there's quite a few people. Maybe we can start. Actually, I'm curious. So you started the first web browser, Mosaic, and we acquired Mosaic ML yesterday.
Yes.
What do you think about that?
You know, if the name is going to get reused, it should get reused for this. So I'm excited.
Awesome, awesome. So maybe starting with that. Actually, I'm kind of curious. So, you know, you've been part of many, many internet revolutions. You've seen it. You've had like the inside, you know, scoop. First the browser, the internet, then social networking. Actually, I don't know if everyone knows this, but you were on the board of Facebook since
2007.
2007. So you saw this whole thing go from like just a place where you check out friends to, you know, this thing that it is today, and now AI is happening. So why did you write this article?
Yeah, well, so AI is one of these things. AI has been around, right, conceptually for a long time, right? One of the interesting things I find interesting about it is it was actually invented as an idea back in the 1930s and 1940s. And so there's been basically this 80-year arc of thinking. And in fact, the original neural network paper that ChatGPT and all these other systems are based on was written in 1943, right? So this has been like an 80-year journey. And AI has kind of been alongside the computer industry and the internet, the entire time. And some companies have figured out certain things to do, but it's never been the kind of main thing in the industry. And then, of course, there's been this huge breakthrough in the last 5 years where all of a sudden it started to work. And so it feels like the moment has arrived. And maybe there's a lot of interesting things to talk about, but one of the most interesting things is why is it happening now? And that goes, a lot to the topic of this conference. Is a lot of why it's happening now is because of data. It turned out one of the things you need to make AI work is just an enormous amount of data. And so it actually turned out we had to get the internet to scale, right? We had to get like the full corpus of the World Wide Web and basically the full crawl that goes into the search engines, and we had to get all the image data on Google Images and videos and so forth. To be able to train these things, and then it turns out they actually work. And then, of course, that means to make AI work even better now means we need to feed it a lot more data. And so it feels like these worlds of like internet, data, and AI are kind of all slamming together. And now magic is happening.
That's amazing. Actually, you had this argument that I read somewhere, which is kind of interesting, is that the previous kind of generation of things feed the next generation. Well, can you explain that? You said books reappear and.
Oh, yeah. So there's this interesting thing. So Marshall McLuhan was this famous media theorist 40, 50 years ago, and he had this thing. He said, each medium becomes the content for the next medium. And so he said basically when like radio emerges, basically what were they doing? They were basically like reading out newspaper articles. When television emerged, what do? They basically televised presentations of stage plays. When the internet emerged, what did it do? All of a sudden it's a platform for all previous media forms, right? Including all of TV and movies and everything else. And then AI is kind of the ultimate example of that, which is then all of these different forms of media basically surge in and become components of training AI. Right. One of the big breakthroughs in AI right now is this idea of multimodal AI. Right. So you basically like if you use ChatGPT today, it's trained on text. If you use Midjourney, it's trained on images. But the new AIs that are going to come out are going to be ones that are trained on multiple media types all at the same time. Right, so you have AI that's trained on text and images and video, right, and structured data and documents and mathematical equations and so forth, and then the AIs will be able to span across all those. And so they all basically roll forward, and it turns out they're all important.
So then, taking this analogy to the next level, what's going to happen next? All these AIs are going to feed the next thing that comes, isn't it?
Yeah. Well, bigger AI.
Yeah, bigger AI.
Bigger and better AI. Well, as you know, like a lot of research in AI right now is basically, so today you train AI with human-created data, and then you have humans do what's called reinforcement learning, where they're basically, the humans are basically tuning the result from the AI. But a lot of the research happening right now is on how to get AIs to basically teach and train each other, right? And so there's going to be this like laddering, this sort of upward cascade where the AIs are going to actually, they're going to train their successors.
So if we get into that then, okay, so it's fascinating. This is going to feed the next thing. So the output of these AIs will train the next AI. And actually, if their output can feed the next one, it seems you now get into this recursive loop, which could potentially happen pretty fast. Yeah. That gets into the whole, the whole doomsday scenario, takeoff, so on. You said it's a category error.
Yeah.
Can you explain that a little bit?
Well, so what happens is there's a sort of idea, and it's sort of a recurring idea in human history. There's sort of this idea that you're going to have something sort of fundamental change in the human experience, and then it's going to lead either to utopia, right, on Earth, right? And the utopia version of AI, right, is this concept called the singularity. Right, and this is this concept originally invented by this guy Vernor Vinge, great science fiction writer in the 70s, and then Ray Kurzweil has carried this idea forward for the last 30 years or so. Right, and so the singularity is the idea that basically at some point computers get basically more sophisticated than human brains, and then all of a sudden you get the singularity, and all of a sudden everything changes and becomes wonderful. Corresponding, of course, to the idea of creating utopia on Earth, there's also the other idea, which is creating dystopia, right? Creating hell on Earth, where everything just like goes completely to crap. And so. The problem I have, I'm an engineer by background, and so these sort of very rapidly to me start sounding like science fiction scenarios. So I don't think this is actually what happens. There's this guy who I like is writing a lot, and he up in Berkeley, and he has this term he calls what we're doing as a species, basically a civilization, he calls we're slouching towards utopia, right? And I like that term a lot, which is like basically it's like things are getting better on the margin, kind of all the time. Like material welfare and health and intelligence and all these things are kind of the capabilities of what people can do are kind of getting better all the time, but they're not getting better in a way that leads to basically an actual literal utopia. But but we're slouching towards utopia. Like in our imperfect and broken and fallen way, right? We do still manage somewhat to improve the world over time. So it's sort of I would say a cautious form of optimism, not the radical form.
Makes sense. So what about the people that then say there's this thing called, I think, instrumental convergence, right. Which actually, can you explain it? So there's this concept of the AI, no matter what goal you have in life, eventually you will converge on some sort of things that you need to do. For instance, gathering energy is important because otherwise you couldn't get towards your goal, or survival is important, and so on. So then eventually these AIs will realize, if they become really, really smart, that they might not be aligned with our interests.
Yeah, so there's a whole. I mean, this gets very deep. So we're going to spend the rest of the day here discussing this. Is that right? This is the next 8 hours.
That's one question on it.
I hope people brought their water bottles because we're going to settle in for the next 8 hours just on this topic. So.
Marc told me before we got on stage, like, if I don't like one of your questions, I'm just going to leave.
I'm just going to like stomp right off stage. There's sort of these two lines of argument. One is like the AI is going to like declare itself its own goals. It's like a Terminator scenario where it's going to wake up one day and decide it hates us. Yeah. And my answer to that is like there's no it. Like they don't. It's not a person. Like it doesn't have consciousness. It doesn't have like a will. It doesn't have any of these things. And then they have this other argument, the sort of so-called AI doomers projecting sort of this dystopia. This other view of like, well, it actually doesn't need to ever have consciousness or sentience or any sort of will of its own. It's just going to somehow like it's basically going to like they're going to like hyper optimize for these small goals.
Paperclip.
So this famous paperclip optimizer, like somebody will make the mistake of telling an AI to like make paperclips, and it will basically decide that it needs to convert all atoms on Earth to paperclips, right? Including it needs to like harvest all human bodies and turn out atoms into paperclips. And in so doing, in order to like maximize the number of paperclips in the world, it will develop its own energies. It'll figure out how to develop nuclear fusion, and it'll have like its own space stations, and it'll have like its own robot armies. It'll have whatever it needs to like maximize the number of paperclips. And it's just like, I don't know, okay, is the problem that it has its own will or that it doesn't have its own will, right? And so I kind of trip it up there. And then there's just like practical limitations, right? And so like a practical limitation is, okay, where's it going to get the chips to run the sophisticated algorithms to make all the paperclips? Because like sitting here today, we can't even get chips to like run AI at our startups. So I have these like fantasies that there's like a baby evil AI, probably running in the lab at Databricks right now with the Mosaic acquisition. It's this like evil baby AI that like wants to take over the world, but like literally it's sent its purchase order to NVIDIA, and like literally it's just not getting the chips to be able to do it. So I don't know. I think we should wait to see. I think we should wait to see the first evil baby AI before we get too concerned about the big ones.
Okay, so let's flip it over. So you said it will save the world, right? And you listed a whole number of things that it has the potential to make better.
Yeah.
Which one is your favorite? And can you walk us through some of those that you're the most excited about?
So the reason to be very positive on AI is because it's in this concept of intelligence. Intelligence is one of these things. It's a very, very interesting topic in and of itself, but we actually know a lot about intelligence because we know a lot about human intelligence. And human intelligence has been the biggest topic of study in the social scientists for the last century. And there have been many thousands of research studies done on the implications of having higher levels of intelligence in people. And it turns out, basically, when it comes to human beings, intelligence makes everything better, right? And that's a very big statement, but it turns out there's like a ton of research to support it. So intelligence basically means that people are going to be more people with higher intelligence are more successful academically. They have more successful careers. Their children are more successful. They're healthier. They live longer. They are also less violent. They're better able to deal with conflict. They are better able to solve tricky problems. They're also, by the way, less biased, less bigoted. They're more open-minded. They're more open to new ideas. And so basically, like intelligence applied to humanity is like this thing that basically makes everything better. And then we look at the world around us, right, including being able to be in a space like this and with each other, and all the sort of work that goes into creating this kind of environment and everything else that we do. And it's all the result. It's not the we didn't wake up one morning and all these wonderful buildings and electricity and everything was just like sitting here waiting for us as human beings. Like it got built by human beings through the application of intelligence. And so we've built everything we have that we like that makes the world work with intelligence. We've just always been limited by our own capabilities, or our own organic capabilities, and now we have the opportunity to apply machine intelligence to all of these efforts, and basically do an upgrade of everybody's capability to be able to do things in the world. Personally, the part that I find most exciting is I have an 8-year-old, and the thing that's sort of most kind of emotional for me is the idea that every kid from here on out, mine and everybody else's kids from here on out, will grow up with an AI teacher, coach, tutor, mentor, advisor, right, ally, right, that will basically be with him or her for their entire lives, and will be doing everything possible to try to make sure that every person basically reaches their full potential. I rolled out ChatGPT to my 8-year-old about a month ago. Installed on his, put it on his laptop, and I was so proud. Like, this is the most amazing thing I've ever done as a parent for my kid. Like, I feel like I'm bringing like fire down from the mountain, right? It's
like buying a computer
to my offspring, right? It's like I'm bringing him like the most important thing he's ever going to have is like the ability to access this thing, and I loaded it up for him, and I'm like, look, you can ask it a question, and it will answer any question you have, and of course he's like, okay, yeah, like duh, like. What else would you do with a computer, right? Like, obviously, it's going to answer all your questions. And I'm like, no, like, this is really new. Like, this is really exciting. And he's like, okay, Dad. So notwithstanding the fact that he didn't understand the significance of that, I understand the significance of that. And I think kids are going to grow up in a very different and much better world as a result of this.
We were programmers, so we were the punch cards for these kids.
I remember every single step that the computer industry had to take to get to the point where you can like answer any question, and like, yeah, no, for him it's just obvious.
So is this the new computer? I mean, some people have argued this is the von Neumann architecture, memory, CPU instructions, programming with precise semantics. That was the previous computer. We re-implemented in this old computer, this new computer that prompt engineering and knowing how to talk to it and extract the information you need from it. This is a new computer, and that's what people should learn. Do you think that there's some truth to that, or not really?
Yeah. So there's a whole backstory here. So there's this great book called Rise of the Machines, where it goes through the history of AI, which in the early decades, back in the 30s, 40s, 50s, was called cybernetics. And it turns out they actually had John von Neumann actually had there was an argument at that time that he and Alan Turing and all these other guys had, back in even the 1930s, even before they got to the point where they had the electronic computer. And the argument basically was, they knew they were going to build the computer. They knew this thing was going to happen, right? And it was an old idea. You know, Babbage had the difference engine idea, and so there was like a 70 or 80 year period where they were thinking about how to build. You know, they had calculating machines and tabulating machines and these things. So they knew they were going to build general purpose computers, and they knew the technology was getting to the point where they could do that. And they actually had this big argument back then: should the computer be should it be an evolution of basically a calculator, right? So should it be a thing, you know, now known as a von Neumann machine? Should it be a thing that basically executes deterministically, right, sequences of instructions that are literally exactly what the programmer tells it to do, right? Or should you basically not do that at all, and should the computer be based on basically the model of the human brain? And right, they actually knew about neurons. Like, they actually knew quite a bit about neurophysiology at that point. And so like I said, the neural network paper came out in 1943. And there were quite a few people at the time who argued, no, we should skip the von Neumann machine, we should just go straight for the brain. But they didn't, right? They didn't have they didn't have the chips, they didn't have the data, they didn't have like all the underlying technology, so they couldn't do that back then. But it was even obvious back then that there were these two different vectors to build two different kinds of computers. The way I think about it is the computer we've had for the last 80 years, the von Neumann machine, is basically super linear, super deterministic, right? Super like every programmer knows, like if you program a von Neumann machine computer and it makes a mistake, it's always the programmer's fault, right? 100% of the time it's the programmer's fault, which is like, you know, as a programmer you always feel guilty all the time because you're like, you know how many bugs are in your code. This is a new kind of computer. This is I call it neural networks. Basically, they're probabilistic computers, right? And what does that mean? Which is like, you ask it the same question twice, it will give you different answers, right? And so just the basic idea that you have a computer that you ask it the same question twice, it'll give you different answers is like an amazing thing. If you word the question different ways, it will give you different answers, right? You know, if you, I don't know, catch it on a bad day, it will give you different answers. Like if the training data changes a little bit, it will give you different answers. If you stroke it, like if you compliment it, right? And or you tell it to like model its answer after like certain famous people, or you do all these basically these so-called prompt engineering is sort of this form of sorcery. It actually gives you different answers. And then it does this amazing thing, which is it will hallucinate, right? It will literally, like, if it doesn't know the answer, it will make up the answer. And people look at that and they're, you know, sort of the engineering mind, you're kind of horrified by that. But of course, you know, if you have a creative kind of bent, you look at it and you're like, oh my God, the computer's actually making stuff up. Like, we actually have a computer that's like creating fiction, which is like a fairly amazing thing.
It's like us, basically.
Yeah, so basically it's a lot like us. Well, this is my conversation with having, you know, a lot of friends of mine are like, yeah, I don't know whether I can use this thing because I don't know whether the answer's correct. And I'm like, well, have you ever worked with a human being, right? Like, this is what we're like, right? And it's like, yes, if a human being tells you X, Y, Z, it's like, yeah, you might at some point want to double check to make sure that they remembered everything correctly, right? But the reason you talk to other human beings is because other people have ideas that you don't have, and they create ideas that you don't have. And so you know, it's amazing we now have both of these. And of course, what's going to happen is they're going to get integrated. Like you're going to end up basically with hybrid systems. You already have this with ChatGPT. You can, you know, if you just ask ChatGPT math or science questions, it will often get them wrong. But if you use the Wolfram Alpha plugin along with ChatGPT, all of a sudden it starts to get all that stuff right. And so I think a lot of what's going to happen now is sort of a practical form of engineering where you'll bring together both sides, you know, both of these architectures, and you'll have computers that can both create and also, you know, answer, you know, do things literally.
So what does it mean for us? Like, I mean, you know, come on, many of us grew up programming, loving it. I mean, it was the art form that it was our craft. We loved it, right? We can't not do it for, you know, a week of our lives. What does it mean for our profession going forward? Is programming, well, I'm not asking if the jobs are going away. I'm asking if programming as we know it, this very structured, you know, semantically unambiguous way of writing code, right, is that not really going to be a thing in 5-10 years? And, you know, really you're doing this English prompt engineering to, you know, work with a statistical computer, or no, programming will probably be around and we'll still need lots and lots of people who can write very precise code.
Right. So I think what's going to happen is I think most programmer jobs, most of the activity, I think it's going to basically go up a level, right? And so more and more being a programmer is going to be like being a manager of programmers as opposed to writing all the code yourself, right?
Great, we're all managers now.
We're all managers. Well, except of course what you're managing, are you managing the AIs, right? And so you know, the way this is going to happen is you start today, you use something like GitHub Copilot today, and it's like, okay, I'm a programmer, I've got the AI, and it's kind of helping me at suggesting things. You know, it's kind of, you know, fixing bugs for me, and so forth. And then basically what's going to happen is as those systems get more sophisticated, you'll be able, as a programmer, to basically give them like more complex assignments. And you'll be able to say, okay, write this code, write that code, do this, do that, and it'll kind of go off and do it and kind of report back. And I suspect what will happen, and today it's like a pairing. It's like a person with like an AI copilot. I suspect what's going to happen is it's going to be like a person with like more than one of these copilots, right? And so I think you're going to have basically like, maybe you start with 2 and then basically 5 and 10, and then maybe like really skilled programmers are going to have like 1,000 of these AI assistants, right? And then as a consequence of that, you're basically going to be able to oversee effectively an army of AIs, and then it's just a question basically of how much time and attention and effort can you put into kind of overseeing this whole thing. I tend to think the really good programmers are still going to be trained for a long time in the fundamentals of how this stuff actually works. In the same way that really good mathematicians are trained. Really good mathematicians are still trained in.
Is math going away because of calculators?
Right. Exactly. Right. Exactly. Right. And so the really good programmers are still going to understand everything all the way down to the metal. But the really good programmers are going to be much more productive. Right? They're going to be able to do a lot more in their careers than they could do before. And then a lot of people who can't code are going to be able to actually effectively program. Right, and there's been a long-running trend through kind of these kind of low-code, no-code tools to get to the point where ordinary people can write programs without having a computer science degree, and I think that's really going to go on steroids. And so I think a lot of people who are not trained programmers are going to be actually creating code.
Yeah, so that's about programmers. If we like broaden it to the job market as a whole, some people say, hey, there's a fixed set of amount of work that needs to be done, and we have this much labor to do that work, and now we have computers that can do a lot of it. So now there's less work to be done, so there'll be less jobs. Right. What's your thoughts on that?
Yeah, so that's sort of it's a classic fallacy in economics called the lump of labor fallacy that you're alluding to, which is right. It's this zero-sum view of the world where there's a certain amount of work to be done. If machines do the work, then humans don't have anything to do. What ends up happening is actually very much the opposite, which is basically when machines can take over things from people, what you actually do is you free people up to actually do more valuable things, right? And so there was a time when 99% of us were basically farmers, right? And then later in the Industrial Revolution, there was a time when 99% of us worked in factories. And sitting here today, there's a much smaller percentage of people who work on farms and factories, but there are many more jobs in total, right? Because a lot of new demand got created and a lot of new businesses and industries got created. And so I think there's going to be just tremendous economic growth that follows from this, huge amounts of job growth. Wage growth also flows naturally from this. Specifically with code, code has this property where basically the world can never get enough of it. Like there are always more programs to write. There are always more things that you want code to do. Nobody's lacking. Everybody knows. Everybody who's in a business knows this. Like nobody ever runs out of ideas for what they want software to do. What they run out of is the time and the resources to actually build the software that they want. And so I suspect what happens is both a massive increase in basically the amount of software in the world that comes out of this, and then also ultimately a very big increase in the number of people actually working on software.
That's awesome. Okay, so final topic I want to touch on because I think it's like really relevant for this crowd here. We've been saying data and AI is the future. I've been saying that the crowd here. You are the future. You talked about legends and heroes. Can you tell us a little bit about that? And how should they? And actually, some advice maybe to the audience. Where we have young folks that are beginning of their career. They're thinking about they're here. Marc Andreessen. You've been able to see 10, 20 years ahead of time, many times before. How should they think about their careers and what should they get into and what should they get good at looking forward?
Yeah, so in my piece, I use the terms legends and heroes. So the legends I refer to is you literally had people, scientists. This is sort of the science side of things. You had computer scientists, mathematicians starting in the 1940s who basically worked for 80 years without really getting AI scientists without really getting a payoff for their work. And I just remember when I was in college, 89 to 94. And I remember, studying AI at the time for computer science, and AI at that point was like a backwater. It was like a discredited. There had been an AI boom in the 80s that didn't work. Like it was a bubble and a burst, and a bust. And it was very bad at the time. And so by the late 80s, AI had been very discredited, and this had been about the fourth of those cycles where AI basically there was a lot of promise, and then it just didn't work. And so I remember that you had scientists working on AI in computer science departments and in labs. Where they would literally be born, grow up, get their PhDs, become professors, teach AI for 30 years, retire, and have nothing to show for it, right?
And pass away. I mean, they're not even.
And pass away, exactly. A lot of them are not here today, and literally, they were working on a set of ideas that we now know those ideas were going to work, but it took 80 years, and so the level of determination and vision right, and courage and insight and stubbornness like required to like devote your life to a field where you never get the payoff. You know, now that we know that if it never works, you start to wonder if they were, you know, completely sane. Now that we know that it works, you're like, wow, they saw the future. Like they really understood it the whole time. They got it. You know, it just needed time, you know, for the whole thing to pay off. And so I put them in the legends categories. And then look, in the heroes category are all the people who are making it work today.
So it could be all of the crowd here,
which
right?
is the whole crowd here. And I use that word specifically because, and I talk about this in the essay, like we're in this kind of cultural moment where just like people are really mad about like everything. Like people, I don't know if people have noticed, but like a lot of people are in a bad mood these days about like a lot of stuff.
It's been a while.
Yeah, the country and the world is in kind of an emotional funk of some kind. And as a consequence of that, you know, any new thing that happens, immediately the sort of arguments come out for why it's bad and horrible and it's going to destroy the world and it's going to like be like this like horrible, you know, if you just read the newspaper accounts of what's happening, it's just like to be this horrible thing. And so I think anybody actually working to make a better world possible through this technology, which is I think what they're doing, you know, I think it's a hero.
So this is, you know, so basically people working hundreds of years, you can finally reap those benefits. So we're really lucky to be alive right now. And, you know, you can all become the heroes of the future.
Yeah, that's
Marc
right.
Andreessen, thank you so much,
Good.
everyone. Thank you.
Thank you, everybody.
Thanks, Marc.
Awesome. Thank you, man.
Thank you.
Thank you, Marc and Ali, for such a wonderful fireside discussion. Today, we're going to hear from the creators of these incredible projects that you see listed up on the slide here. We're going to kick it off with the data projects, starting with Apache Spark. What started as a research project at UC Berkeley, Apache Spark has become the de facto big data processing framework out there. I love the collaboration across industry, academia, and open source to truly embrace and contribute to this project. For our next speaker, we're going to have the co-founder and chief architect of Databricks, who still manages to find the time to be one of the top overall contributors to Apache Spark, to tell us about the latest and greatest in Apache Spark, Reynold Xin. Please join me in welcoming Reynold to the stage.
Good morning again. So, as Ali told you, this is the 10th year of Apache Spark. 10 years ago, we at UC Berkeley donated the project Spark to the Apache Software Foundation. So Spark officially became Apache Spark. In the 10th year, I would like to take a little bit of opportunity to review some of the project's history. Seems like the theme I'm doing on this keynote stage this year, anyway. So Spark started at UC Berkeley, the birthplace of not just Spark, but also BSD Unix, Postgres, RISC, Ray. There's a lot of foundational projects. Right, one thing that's really special about the project is that it has a culture of incorporating bleeding-edge research ideas and make it real, make it into the real-world workloads. And many of this led to also high-profile research publication really move the field forward. And this really what makes the Spark project very unique in its beginning, but the project kept its roots. A couple years after the donation of the project, it has received sort of widespread media attention. For example, IBM called Spark potentially the most significant open source project for the whole next decade. I think that to a large extent become true. Now you might ask, hey, who cares about what IBM thinks? I'm not using mainframes anymore. In the same year, Fortune magazine called Spark the Taylor Swift of data. It's not the first time we showed it at the conference. I finally felt, hey, when I read that, I felt, hey, I could finally explain to my wife and my mom what I do for a living. What it means is really Spark came from nowhere with a meteoric rise and rose to prominence and ubiquity. Right. According to OSS Insights, which is the open source project that tracks all the open source projects, every year in the last 10 years, Spark has been the most actively developed project in big data, with over 3,600 contributors and 40,000 commits. It's remarkable for a 10-year history. Now, but perhaps the most remarkable remarkable metrics what Ali showed you yesterday. The project has been downloaded over 1 billion times. 1 billion times. That's across Maven, PyPy, and also on Databricks itself. So what are the reasons that led to the project's ubiquity? I think there are a few principles behind the project really worth highlighting. The first is that the focus on simple, expressive, and modular APIs with well-defined semantics that makes the program easier to write. But also, more importantly, this API is sufficiently abstracted, so they allow the backend to optimize over time without the programmers having to actually change the code they write. The second, which is often overlooked, is Spark can run virtually everywhere. You can start developing your Spark programs on your laptop without any internet connectivity. I was literally coding the last time I was on the airplane, Spark programs running on my laptop. And then you can use your CI/CD tools in your own network environment, and you can publish your Spark program to the private cloud or the public cloud for execution. This is very important because you don't have to depend on any third party. Everything is self-contained. You don't have to depend on any third party just to even test your program. Now, last but not least, the multi-paradigm extensibility of the project. Spark is available. There's many facets to that. Spark's available in virtually so all the most important popular programming languages in data and AI. Started with Scala. We added Java, R, Python, and SQL later. But there are other ways you can extend Spark. For example, data sources and federation. It's been extended to virtually all data sources. Any data source you name, you could probably find an open source implementation of that data source for Spark out there. And we're in the Generation AI conference here. Spark is a very important part of data science and AI. The 4 most popular AI frameworks right now are probably LangChain, Hugging Face, PyTorch, and XGBoost. And all 4 have native Spark integrations. So despite success, the project's not sitting idle. Right? We're introducing, the community is working on a massive number of improvements, literally thousands of them for every Spark release. We won't be able to go through all of them, but I want to highlight 3 today. That's my personal favorite. The first, Spark Connect, and then Python, and then a new programming language. So we'll first start with Spark Connect. Last year on this stage, Martin and I introduced Spark Connect to you. It's a new way of embed Spark in your applications going beyond just SQL. This year, I'm excited to tell you that Spark Connect is GA in Spark 3.4. Now, it creates a narrow ways for Apache Spark computation. And this narrow ways can be leveraged to create thin clients that can be embedded into different programming languages, applications, and edge devices. So what are the use cases for Spark Connect? First, you can use Spark Connect to connect to a remote Spark deployment in the cloud, in your private data centers, or in a different laptop. You can interactively develop and debug in your IDEs, sharing the same production environment of your actual environment. Enables also developers around the world to much easily create new programming language SDKs for Spark. For example, I already know there are community members working on the Go language support. Any Go programmers here? The Scala 3, Rust, Swift, and also our own Databricks Connect has been upgraded to build on Spark Connect. The second thing I want to cover is Python. As most of you know, Python is the #1 programming language in the data and AI era. But beyond that, Python actually just ended C and Java's 20-year run in the TOB index. We started years ago Project Zen to make Python the first-class citizen for Spark, to really make the PySpark experience Pythonic. And there's been a lot of work that gone into it. But perhaps the most evident and visual one is the autocomplete. In Spark 2, which is before Project Zen was started, if you start using Python in IPython notebook or Jupyter notebook, IPython kernel, you barely see anything in autocomplete for Spark APIs. In Spark 3.1, you'll start seeing parameter names showing up, so it makes it already easier to use. In Spark 3.4, the latest release, you can see full signature along with the full documentation in autocomplete directly, making it much easier to write your Spark programs. Ooh, Now, maybe you don't need autocomplete anymore very soon, but I'll get to that. So a lot of the focus on Project Zen in the last few years has been on the end user's experience of writing Python code using Spark. Now the community is actually discussing how do we make that first-class citizen experience of Python also extend to extending Spark itself. In the past, for a Python shop, if you want to extend Spark to add your own data sources, to define a user-defined table function, you have to learn Scala or Java, because that's the only way to extend it. Now the community is discussing creating Python-based data source APIs and user-defined table functions, so Python teams can extend Spark without learning any new languages. And the community is also working on how do you properly test Spark. It's a remarkably complicated process to test any data programs. It depends on not just the program's logic itself, but also the data. So we're creating a new library that introduces native asserts for data and a lot of other capabilities to make it substantially easier to test your PySpark program. With all of this work, we're really making Python a first-class citizen, going all the way from the end user's experience to the experience of framework developers and more sophisticated users that can actually extend Spark itself. So the last one I'm talking about is the new programming language. Some of you might have guessed, but it's actually a little bit different from what you think about. So by now you've all heard Andre Kapasi said the hottest new programming language is English. My extension of it is that English is the new programming language, GenAI is the new compiler, and Python is the new bytecode. What does that mean? In the last few months, a lot of you probably have tried using ChatGPT to generate Spark code. And not because you didn't know how to write Spark, but because sometimes it's difficult to figure out exactly what API to use or what signature you need. However, ChatGPT was trained on a very large corpus of Spark code on GitHub and probably on the open internet that's full of anti-patterns and full of patterns that might be old. So you actually also often generate code that's not ideal. And in order to improve the code, you start using prompt engineering to tell ChatGPT, hey, please do, for example, use the data frame API, don't use the RDD API. And a lot of you are doing that every day. So instead of you having to figure out what the right prompts are, we're excited to introduce what we call the English SDK for Spark. It's a new open source project that helps you author Spark code with prompt engineering already done by the Spark experts to minimize anti-patterns. Instead of me walking you through it, I would like to just show you what it can do. So with that, I would like to invite Alison onto stage to show you a demo.
Thank you, Reynold. Just set up the computer here. Now, let's do a demo. For this demo, why do I do some data analysis on Spark? I want to see the community contributions over time using the GitHub pull request data. We can use the GitHub APIs to download the data, but wouldn't it be great to use Spark to read the data directly? With the latest proposal to add Python-based data source APIs, we can write a custom GitHub data source in Python and use it to load data into Spark as a data frame. Now, we have the GitHub data. Let's do some data cleaning and transformations. I want to get the 7-day moving average of the number of pull requests created by date. I know I need to use some aggregation and window functions to compute the moving average, but I don't recall the specific APIs. I should look it up. So here's window function documentations and Stack Overflow. What we can see here is that I can already express what I want to do in English. But why does it take so much time to put my thoughts into code? Can we just use plain English? Absolutely. We're able to do this using the English SDK for Apache Spark. It is super easy to get started. You can simply instantiate the Spark AI class and activate it, and all your data frames will be AI-powered. Let's reload the GitHub data and do some data transformations using English. First, let's add a column called date. Let's copy pasting here. Then let's aggregate the number of pull requests by date. Yep, just copy pasting the prompt here. And finally, we can compute the 7-day moving average. Let's copy this over. And now, let's display the results to see if it works. Great, we have the data now. Let's visualize it to see what it looks like. The plot looks good, but wouldn't it be great to also overlay the historical Spark releases on this data and check for patterns? Instead of manually copy-pasting the release data, I can request the data through the createDF function and filter for major and feature releases. Let's see what the data looks like. Finally, here is what I want to plot. We have the 7-day moving average, and the vertical bars indicate the Spark releases. Everyone who has ever tried to plot something like this knows how painful it can be. But now, using the English SDK, it's much easier. You can use it to plot the data with a prompt. Here, I'm simply typing out the plot we want to generate, 7-day moving average, annotated with Spark versions. Let's run the command. And the results look exactly as we wanted. Look how easy it is.
Allison. The number of people that could create this chart without looking up the internet, spending half an hour, is probably in the hundreds in the entire world. Right? But now all of you could do that very easily using this PySpark. And by the way, it also looks pretty obvious that everybody procrastinates. It's no longer on the screen, but if you look at it, right before the commit deadline or version release deadline, the commit activity peaks. So Spark committers totally procrastinates. And right after, everybody takes vacation, and the commit drops massively. So the English SDK for Apache Spark does not just help you write your basic Spark code. It actually helps you with all the stages of your data science or data engineering program, going from ingestion, transformation, verification, explanation, to plotting. Right? Go check it out at pyspark.ai for the English SDK for Apache Spark. Now, there's so much more that's happening with this Apache Spark community that I simply don't have time to talk to you all about. I will encourage you to check out this few talks about it at this conference today. Now next, I would like to invite Michael Armbrust onto stage to tell you more about Delta 3.0, which is probably the most exciting release of the project since the initial introduction of the project. Michael needs no introduction. He's a distinguished engineer at Databricks, one of our earliest members of the company. He's also the original creator of Spark SQL, structured streaming, Delta Lake, Delta Live tables, list goes on. All right. Welcome to the stage, Michael.
Thank you, Reynold. It has been an exciting year for Delta. Things are only continuing to accelerate. In the last year, we've gone up to processing 2 exabytes of data per day. I remember the first time I heard this term. It was just an unfathomable amount of data in grad school that we heard Google was processing. And together with you, we've now scaled Delta to do this twice every single day. Delta is fast. It processes, in some ingestion use cases, more than 40 million events per second. And it's popular. We had over 500 million downloads in the last year. One of the reasons it's so popular is because it's reliable. It's been battle tested by more than 10,000 companies in production. It's open with over 500 contributors adding into the ecosystem, and we're not slowing down. We've got over 80 features that we added in the last year, and I'm going to talk about some of them today. One of the really cool things about Delta is it's the fastest lakehouse format. And this was recently validated by a study done by UC Berkeley and Stanford, and also validated by an independent third party. What you're seeing here is the performance of Delta on TPCDS. And you can see we're faster not only at loading data, but then also querying the data once it's been loaded into a table. One of my favorite parts about the Delta community is Delta RS. For those of you who don't know about it, Delta RS is a complete, from-scratch implementation of the Delta protocol written in Rust native code, and it has exploded in the last year. This is completely driven by the community, and it's really taking off right now. The pretty cool thing about this is because it's in native code, you can use it to link into other ecosystems like Python. And this is, lots of people are starting to use it this way. You no longer need a whole JVM just to query Delta tables. Another unique thing about Delta is Delta sharing. It is the only open protocol for sharing massive amounts of data without being locked into a single vendor's compute platform. The way it works is we actually sign individual Parquet files on demand, so you're still securely sharing your data, but you're always sharing the latest copy, and you don't have to make extra stale copies of it. The ecosystem has been exploding with over 6,000 active consumers and over 300 petabytes being shared per day on Delta sharing. And as with any sharing system, the most important part is the ecosystem. And as you can see, there are lots of people sharing data on Delta. And I'd like to focus on some of the newest that we've just added recently. So Oracle, probably the most prolific relational database ever, now supports Delta sharing. So if you want to do analytics on that data stored in your transactional warehouse, you can do it without creating expensive stale copies. And similarly, Twilio is now unlocking all of the power of their segment customer data platform so that customers can natively query it with any engine that supports Delta sharing. There are a bunch of new features that we've added, including support for structured streaming. As you can imagine, when you have a huge data set, it just doesn't make sense to scan the whole data set over and over and over again. You want an efficient protocol that tells you only what's changed since the last time you read it. And so now it is deeply integrated with structured streaming. We've done tons of improvements on the back end, and so now we've improved query latency by up to 50x. We have full support for OAuth 2, Spark, and Pandas. And then finally, for the CFOs in the audience, there's a pretty exciting development. When you share Delta sharing data on Cloudflare, you can now do that with 0 egress fees, which is pretty great if you know how expensive cloud egress fees usually are. Last summit, we announced Delta 2.0, and we haven't slowed down. This year, with Delta 3.0, we have a whole slew of new features, and I want to focus on 3 of my favorite: the Delta kernel, uniform, and liquid clustering. Let's start with liquid clustering. So liquid clustering is solving the problem of rigid partitioning, which is often required to get good performance, but is very difficult to get correct. Let me start by explaining why it's so difficult to get correct. Even if you pick a pretty reasonable partitioning by date and by customer, there's going to be skew in your data. And enforcing that every single file has exactly one distinct set of partition values is a pretty rigid way to do this. And so you can imagine cases where a large customer has way too many files packed into a single partition, and you just can't filter beneath that granularity. In contrast, small customers will be forced to create lots and lots of tiny files, which is both going to blow up your cost and blow up your query times when you're querying this data. Liquid clustering breaks this down so that we no longer have to partition at these rigid boundaries. Instead, we can look at these smaller data sets and collapse them across this dimension. We can also do it across the other dimension. We can even do it in both dimensions at the same time, picking the optimal file sizes based on the actual data that is present in your table. And it works in both directions. It's not only about combining data, it's also about splitting those whales up so you can filter at a finer granularity. The best part about liquid partitioning is, even though it's less tuning, it's also faster. So when you compare it to Hive-style partitioning, where our benchmark didn't even complete, you can compare it to Z-order clustering, which was the old way that Delta did multidimensional data clustering. Liquid partitioning is up to 2.5 times faster. And it's not only queries that are faster, it's the process of ingestion that is faster as well. When you compare it with Z-order, there is dramatically less write amplification because we are gradually clustering the data as it's added to the table rather than only in spurts when you run the optimize command. One of the best parts about Delta is its ecosystem, and I want to highlight a couple of the new connectors that we've just added. We now have support for Flink, which I bet you never thought you'd saw at a Spark conference. We have support for Trino and the whole Python ecosystem. But one of the problems is, at the core of this ecosystem is the Delta protocol. And we're continuing to evolve this protocol. And we want to avoid getting into the state that we've seen happen with some other Lakehouse formats, where as they add new features, vendors won't implement the complete spec. And now you're forced to choose between using the latest features or querying your table wherever you want to. And that's why we're really excited to announce the Delta kernel. It's basically going to take this 8 different implementations of the protocol spec that exists today and collapse them down into one unified group. We have a JVM ecosystem, we have a native code ecosystem, and it handles the complete Delta spec, both the metadata and the data. So you don't have to worry about deletion vectors or column mapping or whatever else we come up with next in the Delta protocol. You just get your data back from the library. Now, as much work as we do on the ecosystem, there will always be other engines, and we actually think that's great. It turns out that any Lakehouse format is better than a proprietary system. But since we can't control which formats these other engines are going to be able to query, this is a big problem for some of you deciders in the audience. You don't want to pick the wrong format today and then find out tomorrow that IT is forcing you to use some proprietary system that doesn't support Delta. Well, you have to convert all of your data at that point. That's a very scary prospect. But if you squint a little bit, it turns out that's actually probably not necessary. If you look under the covers, all 3 Lakehouse formats are based on the same fundamental principle, which is an age-old technique in databases: multi-version concurrency control. Basically, all the different systems store Parquet files. When they make changes, rather than update the Parquet file in place, they make a copy of that file. And then the real transactional magic comes from this extra metadata that sits on top and says, for this current version of the table, which Parquet file should I read? And since all systems are based on this same underlying principle, we're really excited to announce Delta Uniform. What Delta Uniform does is we have one single set of Parquet files, and then we can create the metadata of any Lakehouse format, so you can query your Delta table anywhere in the open Lakehouse ecosystem. So we're going to take this fragmented ecosystem and bring it all into Delta. And you might ask yourself, is it fast? It sounds really expensive to create all of these different copies of the metadata. And it turns out, as I said before, the metadata is actually a pretty small part of it. It actually costs less than 5% on your write times to enable extra formats. And what's even more exciting is it turns out Delta is better at writing iceberg tables than Iceberg is. When you use Delta to produce an iceberg table, yeah, that's right. Because of the advanced clustering I was just talking about, when you use Delta to produce that iceberg table, you have better Parquet files, and thus your queries run faster. So this all sounds a little bit too good to be true, and it wouldn't be a Spark Summit if we didn't do a demo. So I'm going to move over to my laptop, and let's see how this works. It's a big stage. OK, so here we are in a Databricks notebook. And you can see a very standard create Delta table statement. And all I'm adding to it is this one extra table property, Delta universal format, enabled formats. And I can just list which other formats we want. We're releasing with full support for Iceberg. And we're working with the community to add support for Hoodie. So I'm going to go ahead and run this command. And then I'm going to switch over to another Cloud Data Warehouse. And as you can see, we've got our table here. And if we look at it, Google BigQuery thinks this is an iceberg table. So let's go ahead and create a new query on it. Go ahead and add a star here. And I will click Run. And there it is. It's actually a Delta table. Pretty cool. I wanted to show at least one other Cloud Data Warehouse, but unfortunately, their open format support is still in private preview, and I couldn't get access. But if you do have access, I encourage you to check this out. And with that, if you'd like to learn more, There's a bunch of other sessions today. You can learn all about exactly how Uniform is implemented in this session on Iceberg and Hoodie in Delta Lake. You can hear one of my favorite use cases where Adobe actually converted from Iceberg to Delta. And you can also learn how to build your own Delta connectors with the Delta kernel. Thank you so much.
Please welcome to the stage original creator of Apache Spark and ML Flow, Chief Technologist, Matei Zaharia.
Okay. Hey, everyone. Very excited to be here to host our next event, which is an AI faculty panel with faculty from some of the top AI groups in the world. So we've heard a lot from folks in business, from customers about AI, but I also want us to hear a little bit about what's happening in AI research and what these researchers who are leading the way are excited about next. So I'm really excited to introduce 3 members of the panel today. We have Mike Carbin, who's a professor at MIT and also a co-founder of Mosaic ML. When we started the panel, it was before anything was even happening with Mosaic ML and Databricks, so awesome to have him here. We also have Don Song from UC Berkeley, who's an expert in AI as well as security, and Danielle Arhus, who is the director of MIT CSAIL, arguably the birthplace of AI research in general. So welcome them all to the stage with me. And huge props for Daniela for coming here despite Crutchers being injured. She's amazing. So, we didn't even know about it until very recently. So, yeah. So welcome, everyone. So let's start with some introductions. If you can just each tell us, kind of what you work on, what have you been doing, recently that you're excited about in AI research to give the audience a sense of it. And maybe, Mike, you can begin.
Oh, yeah, sure. So I'm here with my 2 hats on. So my academic hat, where I've been doing research for about 15 years, and of course my Mosaic ML hat, where I'm a founding advisor and having a great time doing work there as well. And of course, potentially our plans to join the Databricks family shortly. And so if you look back to the history of what I've done, where I come from computer systems. And particularly my entire interest has always been in how do I make computers go fast? How do I make them more efficient? And I do a lot of work as well in the programming languages and compilation space. So how do we look at the structure and organization of programs, again, to make them faster and more efficient? And perhaps for this audience out here in the data space and the database space, thinking about things like query optimizers, that's where I spend a lot of my time. But how did I get into AI? Well, in some of the work that I've done with my students over the past several years, what we've done is we looked at the structure and organizations of neural networks themselves to identify there's parts that perhaps don't matter. So we can take these very large models, turn them into much smaller models, perhaps an order of magnitude smaller, but still train just as well and still give you good, amazing results. And over at Mosaic ML, these perspectives towards efficiency is what we've been driving based on those insights of how can we take these large models and make them much more accessible for you and everyone else that's out there, right? These models aren't only in the hands of the largest organizations, they can be in everyone's hands.
Great, yeah. Don?
Great, yes. So I'm a professor in computer science at UC Berkeley, and also have a startup working at the intersection of AI security and decentralization as well. So there are so many exciting areas that we have been working in the areas related to AI. So here I'll just talk briefly about the areas at the intersection of AI and security. So given all the amazing advancements of AI capabilities, LLMs, and so on, so of course, one application domain that's really exciting is in the security domain. All these advancements in LLMs and so on can really help a lot in the security application domain. For example, some of our recent work showed that by even just using ChatGPT and these large language models, actually it can really help significantly improve, for example, security audits of applications. For example, we were able to show that it can significantly improve the manual audit efforts for security audit for smart contracts. And also we showed that by using these large language models trained on, for example, blockchain transactions and their execution traces, we can identify anomalous and malicious transactions. And for a broad spectrum of different applications that we examined, these trained models can actually rank attack transactions in the real world to be actually the most anomalous transactions for over dozens of different real-world applications. And these attack transactions actually have caused close to $300 million worth of damage in the real world. So this is just another example illustrating the power of these new large language models and the AI capabilities. And on the other hand, of course, these type of capabilities also pose a lot of challenges. That's also something that we have been studying. For example, showing that these large language models, they have big privacy leakage problems. And also some of our recent work in collaboration with Meta has been on how we can enable privacy-preserving AI model fairness assessments. And this actually is the first of its kind, large-scale real-world rollout that's been rolled out to Instagram users to help for the first time in a privacy-preserving way to assess the fairness of AI models that's actually being used in the real world. So these are just some examples of exciting areas that we've been working in.
Very cool. And Daniela?
Well, so I'm also here with multiple hats. I'm a professor at MIT. I run CSAIL. My former students and I have a number of companies in the space of AI, and it's just such an extraordinary moment for our field, and in particular for AI. Now, at MIT, what I'm most interested in is really asking some foundational questions about what AI can achieve. And so if we think about the fact that the majority of the successes we hear about today are due to decades-old ideas that are now empowered by data and computation, it's kind of natural to ask, what else is there? Because if we do not come up with new ideas, in time, everyone will be doing the same thing, and the contributions will be increasingly incremental. And so I'm super excited about a new approach to machine learning, which we call liquid networks. It's a compact approach to machine learning it's a kind of a continuous time approach for applications that have time series data. Liquid networks are compact, provably causal, and they have very nice generalization properties when trained in one environment and applied in a different environment with really huge distribution shifts. And so, the world is trying to make networks bigger and bigger. I want to make them smaller. And so to give you a sense of what you can do with liquid networks, in our work, we do a lot of edge device and robot applications. And so, for instance, if you want to get a robot car to stay in lane and steer, it takes about 100,000 deep neural networks to get good behavior. And it only takes about 19 of our liquid networks. And so if you have a solution that involves only on the order of a couple of nodes, or maybe on the order of tens of nodes, you can then extract decision trees to explain how that system makes decisions. And in doing so, you can begin to address safety-critical applications where knowing how the model reaches decisions is very important.
That's super cool. Yeah, I do think now that we've gotten neural networks with gradient descent working, people will discover so many other ways of doing this kind of computing and in a much more controllable way. So super exciting to hear about that. So one question I had for all of you is, as researchers, you see a lot of the emerging ideas in AI, and here we have an audience with many practitioners who are, building things every day. So what's an idea or an approach you think is coming up in UI that, in AI that is looking promising and that you think practitioners need to know more about, that they aren't paying enough attention to? So curious what each of you think about that, if whoever wants to, yeah.
The eyes are on me. All right. Let's see. So we're at a big data conference. I guess I actually want to say small data. And so what I mean by that is there have been some interesting results, some things that we've been working on, some things that other people have been working on. And a highlight I think you can look at from the past couple weeks, it's maybe a month old at this point. There's this paper, textbooks are all you need. Now it's important if you see a paper that's out there in academia, sometimes it's less about the result and more about the idea, as we're talking about here. But what they were trying to do, they wanted to go out and build a code model, like a code generation model, sort of like what you were seeing yesterday in the Lakehouse IQ example, the Lakehouse Q demo, where large language model is going to generate code. And the typical way that you're going to do that now is you can find as much data as you possibly can. Scrape the internet, Stack Overflow, all these data sets that are large and pretty dirty in some ways. Throw them into a model, and this thing will amazingly generate code. Really great. But these models are large. Right? We're looking at ChatGPT, in that, at least in the 3.5 ChatGPT with GPT 3.5 in that 150, 175 billion parameter range. These are large, these are massive, right? And we think these models are perhaps out of the reach of many. But in this paper, what they did is they find, again, small data. If you do a very good job of trying to curate your data, you can find these opportunities to process on less data, orders of magnitude less data, and with orders of magnitude smaller model. So they had a 1.3 billion parameter model that was besting some of the best models that are out there in the 15 billion parameter range, and even exceeding, at least in their domain evaluation, the results that you're getting out of ChatGPT, driven by GPT 3.5. And so I think that's the future, this future of focus, right? ChatGPT is absolutely amazing. It knows everything in all these different domains. But when you can focus on your particular domain and your use case, I think they're really good opportunities for building these models and building these models yourself at a scale that's accessible to you. And so that's the direction I see, because I know everybody's thinking about ChatGPT. But these new coming directions with these smaller models, I think are very promising.
Very cool. Yeah.
I think for practitioners in general, practitioners are really excited about these new capabilities. I want to use them in different applications. And so on one hand, it's really exciting to see all the great progress and cool things you can do about it. But on the other hand, I think one thing that usually practitioners maybe don't think enough about, that's the thing that I wanted to emphasize here, is that often because these services are exposed to the general users and so on, like you have to think about how these services may be misused, for example. These AI models, with our work and with other researchers' work in the community, these models have a lot of security, privacy challenges and issues. And they can be easily, it's called jailbreak, and also they can be fooled in giving wrong answers. And also, as practitioners use models out there, actually, there has been, our work and others' work have shown you can very easily implant, for example, these, we call them backdoors or trojans into these models. That's very, very stealthy. You don't even know that they're there, but actually, then the models can be triggered under specific conditions to misbehave. So this is just the tip of the iceberg. There are lots and lots of these different types of security, privacy, and other types of trustworthy issues with these AI models and how they can be properly used in the application domain in a responsible way. And I think one of the really big challenges actually for practitioners for deploying these models is how do you know when the models are actually ready to be deployed? How even to measure how the model essentially behaves, or what are the metrics for measuring the trustworthiness and the different aspects of the model. So one of our recent work with my wonderful many collaborators is called Decoding Trust. You can actually go to the website decodingtrust.github.io to look at more details. So this is the first really comprehensive, systematic evaluation framework that covers a full broad spectrum of different aspects, different metrics in the trustworthiness of AI models. And this is only just the first step. We hope that this, as an open source framework, we can encourage the community to come together to further develop this, to really help practitioners to know better how their models are doing, besides just the performance perspective, but actually more in this broad trustworthiness perspective, to really know when the model actually is ready to be deployed. If not, what are the issues and so on.
Very cool. Yeah.
So we can talk for a long time about the excitement of the work in academia, because despite the fact that we have such extraordinary potential from AI, there are a lot of problems that need to be addressed in order to make AI safe and trustworthy and environmentally okay and easy to deploy. I guess Don was talking about how do you know when the model is ready. Thinking about rigorous approaches to testing and evaluation is super important. Thinking about how we build trust in how we use these, how we use AI is super important. But if I can pop up at one level, I would say that when I think about how AI is used today, there are basically three categories of AI solutions. We have AI solutions that are primarily about pattern recognition. And this is where deep learning and variance kind of fall. And then there are AI solutions that are primarily about deciding what to do. And this is the kind of the body of work around reinforcement learning. And then there is the group of AI solutions that are all about generating new things. And this is the generative AI space, which includes tools like GPT. And in each of these areas, the academia is actually working to better understand what kind of solutions we get, to increase the representation. In other words, what can the models represent and recognize, and also to really understand the properties. And I will tell you that in each of these three categories, we have issues. We have issues around data, because they all require a lot of data. And that means that the computation is huge. That also means that there is a large environmental footprint. I mean, did you know that deploying a very small, for today's standards, model today releases 626,000 pounds of carbon dioxide in the atmosphere? This is equivalent to the lifetime emissions of 5 cars. So as we think about deploying AI in the future, it's important to keep these numbers in mind, because we want tools that support humanity, but also the planet. So we have to deal with data, we have to deal with computation, we also have to understand the black box and ensure trust and privacy in our solutions. And so the good news is that the academia is working on all these problems, and next year when we come together at this meeting, we can report to you on more achievements.
Makes sense, cool. Yeah, I think we have time for a couple more questions. So so let me try to think about some of the more interesting ones. So okay, so one question I have for everyone that I think is on everyone's minds here is, what do you think about AI becoming sort of democratized or commoditized? So like on the one hand, things like computer vision, you can run pretty much anything that's state-of-the-art on your mobile phone. On the other hand, we've got large language models, which are extremely large, and it seems making them larger makes them even better. What do you think about the technology trends? Will this be something that kind of everyone that will get a lot cheaper, that everyone can do, or what are sort of the pro and counter arguments for that?
Yeah. I've already said it.
Yes, we know. You believe.
I can just say it over and over again. Yeah, I think these are the trends that are taking over. And when we talk about democratize, I still feel like I want to break that into two different categories. One is, we see ChatGPT, and it's absolutely amazing. Again, like I said, it knows literature and the arts, sports, pop culture, right? Anything that you can think of, right? I mean, it's truly, truly revolutionary, I have to say, when I first sat down and started using it. I hadn't expected to see these types of capabilities, particularly in the interactive code generation, sort of getting back to my domain, perhaps in my lifetime. Truly amazing. I think in that space, we're already seeing democratization in the sense of increased competition, right? I mean, Bard, Claude, Pi from Inflection, results that we're putting out at Mosaic. There's a hot race, right? The economics are there to bring down the costs of those models. Now, I think there's this other direction as well on, can you build these things yourself, right? Perhaps it's great that there are these closed models that are out there that you have access to, but could you build this yourself? And I think the trends are positive there as well. So going back to what I had said before, this textbooks are all you need result. If you can focus, right, again, so ChatGPT can do everything, but if you're building a biomedical model, do you need your model to give you sports statistics, right, or talk about Taylor Swift? No, right? But with ChatGPT, you're paying for all of that, right? You're paying in terms of the amount of data. This model needs to be trained on all of this data. You're paying in terms of the model size. The more data, the more recall you need over a larger knowledge base, the larger the model needs to be able to do that effectively. So if you can focus, there's opportunity there, right? And textbooks are all you need. There's an example there in some work that we've done at Mosaic. We actually did this in the biomedical setting where we trained a small, by, again, relative measures, 3 billion parameter model on PubMed, which is this huge biomedical corpus that's out there, biomedical papers, scientific papers. And then fine-tune this to actually respond to questions on the USMLE, so the US Medical Licensing Exam. And we set state-of-the-art results. Of course, that was back in December, and we were able to beat models that were 120 billion parameters at the time because we were able to focus. Right? So for me, it's about focus. And I think those trends are in the favor of everyone sitting in this room where you've got really interesting data, and it's just about focus being on that data and building models around that space.
I can jump in if you. So I think that there is already democratization. Like everyone uses ChatGPT, no matter what aspect in work and also in life. And the tool is extraordinary, but the concern is that people don't actually understand how it works. And so, so this actually causes a lot of problems with how the tool is used and how people respond to the fact that now we have these extraordinary tools. And I would say that it's important for the public to really understand what tools we put in their hands. So communicating to the public and educating the public is important. And that begins with highlighting that indeed, the tools we have today are democratizing our access to information. They're kind of giving a microscope into the digital universe. But this microscope is going to make mistakes. And so it's not about, so using the tools is not about replacing activities, but about augmenting the human with some extraordinary new capabilities. I like to tell people that they should think about using an AI tool sort of like they think about an assistant. The assistant runs around, looks for patterns, brings interesting data for the decision maker to act on. The human really still has to stay in charge. The other thing I will say that this democratization is causing a lot of fear in the population, fear that a lot will be replaced by machines, and this is just not the case. And so we have to be careful with how we excite people about being empowered and augmented with new tools rather than being replaced by these tools.
Cool. And yeah, one more quick fire round because we're running out of time. So just quick answer. Obviously, everyone's very excited about LLMs now, but there are so many other types of data, so many other types of applications, interactions we can apply AI on. What do you each think is going to be the next area to get a ChatGPT-like moment?
Liquid networks.
Okay. Very general, yeah.
Area. Oh no, I'm still processing ChatGPT.
He said short.
Done.
Oh, I mean, also following up a little bit to the previous question, I do think, this democratization, there are many different aspects to democratization,
you
right?
have good negative results in this space.
Yeah, right. So, like this, you can look at it's also open versus closed source, and also ultimately, we talk about this personal assistant that helps individuals, but who actually controls these personal assistant, whether we want to just have the big tech companies have closed source models to control that, or we want to have open source models where actually individuals really can have these kind of personal assistants that's actually under their control and really try to act in their best interests. And following Mike what earlier said, essentially, so recently we had some results talking about the challenges for building open versus closed source models. We had this paper on the false promise of imitating proprietary models.
Imitation is not enough, yeah.
Right, so like, it's not so simple. You actually really have to do the hard work to improve the performance and the, of the base model and so on. So there's a lot of challenges, and how can the open source community to come together to make that right, to really try to close the gap.
Yeah, so the training process, makes sense, Cool.
Michael?
I think I just want to say multimodal, right? So
multimodal,
multimodal. I'm required as a programming languages person to say code generation, but just multimodal. So I think we're just in this age where we suddenly have the capability to have multimodal interactions with computers, and the fact that that's going to bring so much new capabilities, so many people who could previously only access computation via programming, right? And perhaps those people were excluded. I think that's just the future. More computation for everyone.
So I do want to jump in because I only had 2 words. And I will say that I agree with everything my wonderful colleagues have said, but I think we also need to understand what's happening in the box. And so aiming towards causal models is important. And the other thing that's important is to get a better understanding of what's happening inside the box, because ultimately we will get to the point where we will need certification, or we will need some kind of deployment guarantees when we put AI in service, especially of safety-critical applications.
Very cool. Well, thanks so much, everyone. Really awesome to have you here.
Great, thank you.
Continuing on with our theme of open source projects and democratizing data, our next speaker is the co-creator of DuckDB. I love DuckDB. It actually has all of the benefits of a real duck when applied to database management, including versatility and resilience, but without the quacks. Last month alone, DuckDB had more than 2 million downloads. So please join me in welcoming Hannes Muhleisen to the stage.
Thank you, Brooke. Yes, hello, good morning. My name is Hannes Muhleisen, and I'm here today to talk to you about DuckDB. But I would like to start with a small story. This is my actual car license plate from my first car 20 years ago. And what you can probably tell from this is that I may have been a database nerd back then already. In fact, I love these things so much that I went on to do research, and this is where I met Marc, who is here today, and we were starting to think about new ways of building database systems, and we were doing that in Amsterdam at the CWI, which probably you have not heard of, but it is the Dutch National Research Lab for Mathematics and Computer Science, and it's the place where Python was invented by Guido van Rossum all those years ago. So it had a certain impact on the world. But while we were there, we started feeling that there was something wrong with the world of data. And I should explain, it's a movie from the 90s. In this movie, this character tells another character that he knew there was always something wrong with the world, but he couldn't quite put his finger on it. And we had the same feelings, that there was something sort of off with how people were doing stuff with data, and that we should probably do something about it. And one thing we noticed after many years of thinking about that is that what was happening is that were people using very big iron systems like Hadoop to solve fairly small data problems You know, stuff that's a bit too big for Excel or Pandas or something like that. And by using some big iron for something small, like here this sledgehammer to crack a nut, apparently that's an expression, you just get bad ergonomics. In German, we have a saying, to shoot at sparrows with cannons. And in fact, there was a development that has sort of supported this, where we now have data lake formats built on things like Parquet that actually have the ability of turning a huge data set, a very unwieldy thing, into something much more manageable. And we can, with formats like Parquet, we can actually very precisely fetch only data that is relevant to a specific query. What also has happened is that we got a disconnect between storage and compute. And I know you know this, and people have talked about this before, but I feel it's the difference between knowing that something is happening and appreciating all the possible consequences of it. And one of the consequences that these things are disconnected is that we can scale down compute to the appropriate size that's sufficient for the problem. And you would be really, really, really surprised how small you can scale down data problems. In fact, the laptop in front of you is more powerful than you think. So if the data is small enough, there's no reason not to put it on your laptop. Another thing that we've noticed while thinking about having the splinter in our minds about data systems was that the community was spending a lot of time thinking about the meat of the hamburger, the patty, apparently it's called. And this was great. You can write a lot of interesting research papers about things like join algorithms and things like that. But the problem is you're not looking at the whole hamburger, right? You're ignoring the end-to-end user experience. And that was such a problem that people had like aversion towards data systems because they were hard to handle. And so we decided we were going to work on making an end-to-end good experience for data systems for once. So the result of all that thinking and sort of like long 10-year process almost was that a whole new class of data systems was required. And the first instance of that class is DuckDB. So DuckDB is an in-process analytical data management system. It does SQL, and I will tell you more about it in a moment. But first, the first question we always get is, why is it called DuckDB? It is because I used to have a duck. His name was Wilbur. He is a very cute duck. DuckDB is very flexible. It runs really anywhere. It can run from a Raspberry Pi to a huge server. It has a very small footprint, only 20 megabytes. And it has no dependencies. It's like just a C++ project, and that's it. DuckDB is very feature-rich. We have a very large sort of SQL dialect where we have all the features that you would expect from a modern analytical SQL engine. It has integrations with Python, a lot of other languages, Arrow integration, and can, for example, directly read Parquet files. DuckDB is fast. We have a state-of-the-art vectorized so-called query processing engine, and that comes directly from the sort of state-of-the-art research that we did at the research group in Amsterdam. For example, DuckDB can also automatically parallelize queries. So you give it a query, and it will figure out how to use all your hardware resources. DuckDB is free. It's free as in free beer. It's MIT licensed. Do whatever you want. Build a company on top of it. It's really up to you. But let me zoom in a bit into some things that make DuckDB different. DuckDB is not a client-server system, and I know that is also something where it's a bit of a departure from what people are used to. All data systems under the sun are client-server, and that has been unquestioned since 1984. But DuckDB is in process, meaning the database runs directly in the application, and that means you can directly access data in the application. And in fact, I'm going to show you a quick demo on why this is amazing. Here I have a Python script where I create a data frame with 1 billion rows. It's about 8 gigabytes in memory. And now I can spin up a DuckDB instance in that same Python shell because it's in process. And I can run a query, and it will only take 160 milliseconds or so to go through these billion rows and compute the average. And that has to do with, yes, the database has a state-of-the-art engine, but it also can directly access the data in your memory of the Python process. But let's zoom out a little bit. How does DuckDB fit in a typical architecture? We have our data lake, we have our analysis cluster, and we have the laptop with the analyst. Well, very often the first step is that we do ETL. We take the big unwieldy data set, and we transform it into a bit more manageable data in like data lake formats or Parquet. But meanwhile, the analyst sits idle. And then we do the analysis project where we do explore and we try to find out something about the data. And we use the cluster as well. And this works really well, but it creates contention with other jobs running on the cluster, and it slows down analysis. With DuckDB, you can actually move the exploration and analysis on the very laptop that the user sits in front of. And it has one real advantage, is there's no contention. You have your own laptop. It reduces latency and just generally reduces load on the cluster. Everyone's happy. Let me show you another demo here. Here I'm now taking the DuckDB, the famous New York taxi data set. It's about 90 gigabytes of data. It's in Parquet format, and it's about 1.7 billion rows across 50 columns. And I'm just using DuckDB in this shell here to set up the view with the trips. And now I can run, for example, a very basic query where I group the number of, where I count the number of trips per cab type. And this query has to look at all this data in this huge data set, and it finishes in under 3 seconds on my 2-year-old MacBook. So that is really something that you wouldn't have thought, that you can run these huge data sets on a normal MacBook, right? You can also have a much more complicated query. For example, in this query, we compute the number of trips per amount of passengers, the year in which they happen, and the distance. So this is a bit more complicated, and I'm not going to expect you to read the SQL query. But even this more complicated query will finish within under 10 seconds. But how does DuckDB fit into the machine learning space? Well, we are not doing machine learning. We are database people. We're simple-minded. But as you probably know, the process of preparing data for analysis is one of the things that you spend most of your time on if you want to do any sort of ML problem. And DuckDB actually fits really great into that process, because I mentioned you can pull a Parquet file, you can do a lot of reshaping, wrangling, figuring out what features are required, creating new features, all that. You can do all that in DuckDB. And then we have integrations with systems like PyTorch or TensorFlow to directly ship the results of this reshaping that you're doing to these libraries. And the cool thing is that because DuckDB runs in process, we are already in the same environment that the ML library is also going to run in, which means the transfer is near instantaneous. So now I hope I have given you some reasons to check out DuckDB. Here is some pointers, but with that, I thank you for your attention.
There must be something in the water, because LLMs are the talk of the town. If anybody has tried building an LLM-powered application, they have very likely used LangChain. It's incredible that this tool that we all depend on and use was only open source less than 8 months ago. It is one of the fastest growing open source projects out there and had more than 2 million downloads last month alone. So please join me in welcoming co-founder of LangChain, Harrison Chase.
Thank you, Brooke, for the introduction, and thank you, Databricks, for having me. My name is Harrison Chase, CEO and co-founder of LangChain, and I'm really excited to be here. So what is LangChain? LangChain is an open source developer framework for building LLM applications. We started as an open source Python package in October of 2022, right in between Stable Diffusion and ChatGPT, and then we quickly expanded to have a TypeScript package as well. We kind of came about right at the time where there was a massive increase in the number of people interested in building applications with language models. And so I think we've been really fortunate to have an amazing community that's helped build with us and on top of us. And so I think that's reflected in, these numbers are a little bit out of date. We have over 1,000 contributors. And so I'd also just like to take this opportunity to thank everyone who's contributed in part to LangChain. So yes, yeah, that's the most important part to clap at. So what is LangChain? So I think of the value props of LangChain in two separate ways. One, we have a lot of components. And these are all the building blocks that are necessary when building LLM applications. And so at the core of LLM applications are the models themselves. And so what LangChain provides is a standard interface for interacting with over 40 different LLM providers, hosters, everything in that spectrum. We also provide tools for managing the inputs and outputs of these LLMs. So at the very basic level, the inputs and outputs are strings. But of course, a lot of people are having more kind of like structured inputs. So you have a bunch of different variables and user inputs and chat history and few shot examples that go into this what ends up being a pretty complex input to this LLM. And so we help manage all of that state. And on the opposite end, we have output parsers, which help take the output of the language model, which is a string, and parse it into something that's useful downstream. Because the main way that we see people using LangChain is not just to call a language model, but to use it as part of this system. And so that naturally involves connecting it with a lot of other components. And we have a lot of integrations with those other components as well. So document loaders, we have over 125 different places to load documents from and then split them into chunks. And this is very important for when you want to connect these general models to your data and enable them to answer questions about your company, your personal files. We have an integration with over 40 different vector stores, again, all with a standard interface so that you can start with a local vector store and then quickly transition to a cloud vector store when the time comes. So that's one of the value adds of LangChain, which are these little building blocks, basically, which you can assemble in various ways to build an end-to-end application. And then on the other side, we have use case-specific chains. And so we see a bunch of common patterns in how people are building LLM applications, and we put these into chains to do question answering over documentation, question answering over CSV or SQL or any type of tabular data as well, adding a natural language layer on top of APIs so you can chat with your data that are behind APIs, extraction, so extracting structured information from unstructured text, and a variety of others. And so to summarize, LangChain, I think of as two value props. One are these individual components, which you can easily use and assemble and are interoperable to build your own applications, and then these chains, which are easy ways to get started. For the rest of the talk, I want to talk about three of the main areas that we're really excited about at LangChain. So the first one that I want to talk about is retrieval. And so the problem that retrieval solves is that language models like GPT only know the data that they were trained over. And so that's useful, and they can answer a lot of questions, but when it comes time to using them to answer questions about recent data or your personal data, they can't do that by themselves. And so a popular technique for allowing them to do that is a technique known as retrieval augmented generation, where you first do a retrieval step, and you provide that information in the prompt and ask the language model to answer based on that data. And so the benefits here are that you don't need to retrain a model, and so you can use any of the commonly available APIs off the shelves. And then this also helps ground the model and reduce hallucinations so it doesn't make things up. So the common workflow that we see for retrieval is when a user question comes in, we first do a similarity search and retrieve from a vector store various docs and various chunks of documents that are relevant for that question at hand. And so behind all of this, there's also a separate ingestion process. And this is where the document loading comes in play, where you can load document from, let's say, your Notion. You can then split it into various chunks, and the reason you split it is so that you can then retrieve only the most relevant ones. You then create embeddings, and you put them in a vector store. You then pass them into a prompt and ask the language model to answer based only on that question. And this is the standard solution, and it will get you about 80% of the way there. What we've seen and what we're really interested in is advances on top of that, advances that help go from that 80% to a more reliable 95%. And some of the edge cases that pop up that necessitate these advances are things that happen when you have conflicting information, or information that changes over time, or when you have queries that aren't just about the semantic nature of a document, but also refer to some aspect of the metadata. And so we have a lot of different layers on top of the basic similarity search inside of LangChain to help get started with that. Another area that we're really interested in is agents. And so agents is a bit of an overloaded word. Everyone kind of has a slightly different definition. The one that I like comparing agents to chains is that chains are a sequence of predetermined steps that you have coded in code, while agents use the language model as a reasoning engine to determine what actions to take, and then it goes and does that action, offloading any knowledge or computation to that action. It gets back an observation, and then it passes it back in. And so the standard solution for an agent is effectively a while loop, where you ask the language model to think about what to do. You then go execute that action. You get back an observation, and you repeat that until the language model recognizes that it's arrived at its final answer or that it's completed its objective. And so we have some infrastructure around that, and then we also have various prompting techniques like React, which is a paper that came out last October, stands for Synergizing Reasoning and Acting, and it's designed to more effectively enable language models to think about what to do and take actions. And so we have these as part of the standard solution and standard offering in LangChain. We're also really interested in advances in agents. Agents are one of the most fast-moving spaces, and so we're paying really close attention. I'm really excited by plan and execute style agents, where instead of going one step at a time, you do a planning step. You then execute the first step in that plan, and then you return to the planning step and kind of adjust the plan from there. And this helps with longer running tasks. And so this was heavily inspired by a lot of work in the open source by projects like Baby AGI, actually, and things like that. Another area that we're paying really close attention to is tool usage. So tool usage involves the language model taking an action. And so this started off where tools were functions that accepted a single input, and that input was just string. And that was because language models back in October were only really good enough to input that single string. Now they're getting good enough where they can input more complex structures with multiple function calls. And so we're working to support that and push that forward. The last area that we're really excited about is evaluation. And we're excited about this because right now, I think there are a lot of people prototyping, and there's not enough people putting things in production. And I think the gap between prototyping and production exists because it's really hard to get the more complex applications reliable enough to a point where you can trust them in production. And part of that is evaluation and gaining that confidence. And so there's two main issues that we see with evaluation for LLM applications. One is a lack of data, and then one is a lack of evaluation metrics. You don't start with data with a lot of these LLM applications. You start with an idea, and these language models are fantastic zero-shot learners, and you can get started really quickly, but then how do you know how well it's doing? And then on the evaluation metric side, traditional ML metrics like accuracy and MSE don't quite cut it here. And so one of the things that we're working on and we're excited to announce in a few weeks is a platform to help with this, help with enabling both the collection of data as well as the evaluation of it. And evaluation of it comes in a few different forms. There's traditional metrics, but it's also just making it easier to visualize and understand what's going on. The most common way to evaluate is a vibe check, which sounds bad, but it's actually, it makes sense that that's the best way because it's really complex, and allowing people to gain that insight as to what's going on is important. And so we want to help with that as well as more advanced metrics. We also have a ton of integrations with Databricks. So we support the LLM endpoint, we support ML Flow, and we have an integration with Spark, both chains and agents where you can interact with your data. And the best part of all of this is that you can run LangChain from inside Databricks. And so that leaves me with the question, we're here, this is a generational moment to build things with ML and AI. And so I hope that you guys take advantage of LangChain, take advantage of Databricks, and what are the amazing applications that you guys are going to build. I'm excited to see, and please share them. So that's all I've got. Thank you guys for having me. Have a great day.
Thank you, Harrison. LangChain loves Databricks, and Databricks loves LangChain. The Databricks Assistant, which is live, check it out, was built using LangChain. In order to power these LLM applications, though, we need a framework to build our language models. And according to Papers with Code, the most popular framework to do that with today? PyTorch. For our next speaker, we have the former head of PyTorch, who's going to talk about the past, present, and future of AI for developers. So please join me in giving a warm welcome to Lin Qiao, CEO of Fireworks.
Hi, everyone. I'm Lin. Today, I will talk about developer-centric AI, the past, present, and bright future. I have always been passionate about building awesome tools, giving to developers to do the best in their jobs. When I started my career, I built one of the earliest in-memory columnar databases, fast document store with inverted indexes, and many data tools from logging, metrics, experiment platform, and so on and so forth. I moved to AI about 6 years ago, seeing a huge surge of data volume driven by AI workload. I led PyTorch team at Meta, accelerate AI researches in open source, and bring huge production workload in production at Meta scale. After having done all this, I started Fireworks.ai with Ning, Dimitro, and an awesome group of engineers. Continue our journey to bring awesome tools to a broader set of developers here, including all of you in this audience, and help you to be the most equipped, prolific, creative in this new AI generation. Fireworks aim to accelerate product innovation, building on top of GenAI. We offer experiment and production platform where you can get access to the most state-of-the-art research of open source models, bring your data, and use our pre-built tuning evaluation recipes, customize your model, deploy easily into our inference services, optimize for cost to serve, and then we free you up to focus on your product innovation, ideation, and iteration. When your product idea is ready to deploy full speed, full scale to production, you continue to stay with our inference service and go from there. Before I talk about more details of product and why us, let me start with where AI journey began. AI and deep learning is not new concept. More than 30 years ago, Yan LeCun, as one of the pioneers of deep learning, published a paper in 1989, backpropagation applied towards handwritten zip code recognition. The model still reads very modern today. From that point, for many years, AI remained as a research topic. Researchers need a maximum amount of flexibility to innovate and maximize model quality most efficiently towards the training data they have. When we started, PyTorch was started for researchers to explore and innovate faster. And we observe around every 3 years, major model architecture disruption happens, and every few months, significant incremental improvement on model quality happens. The pace of value created by research hasn't slowed down, but accelerated in recent years. What is PyTorch? You can think about it as NumPy for AI, accelerated by GPUs, TPUs, your accelerators. Of course, it runs on CPU as well. PyTorch uses model as code philosophy for dynamic neural networks, including dynamic shapes, control flows. Those are essential for AI researchers to disrupting building blocks in AI. Why model as code is so good? Because program first structure is the most open and composable, as opposed to rigid closed systems with hidden functionalities. Many research institutions, including OpenAI, switched over to use PyTorch a few years ago for its flexibility to accelerate their innovation speed. So many researchers become entrepreneurs or move on to deploy models in production. Production deployment shifts the focus on system performance, stability, versioning, scalability, cost to serve, and so on. As you can see, there are quite natural tension across these two cohorts of AI developers. Researchers naturally gravitate towards breakthroughs and break current paradigm to new ones. And production developers optimize for current paradigm. PyTorch continue to speed up research to production transition by ease the tension in between. And that's my focus in the past 6 years. One of the most important use cases we innovate on is ranking recommendation, because it's everywhere in our digital life. PyTorch team released recommendation libraries last year, driving more than 10 times performance improvement and memory utilization reduction. It makes the large, complex recommendation model practical to be deployed into production. We continue to bring more awesome models on mobile devices, which is more resource and power constraint. It requires order of magnitude improvement of reduction of PyTorch runtime size and the latency improvement. As you can see, there are many cool features we enabled through this on mobile products. PyTorch is today deployed very broadly in production, driving more than 50 trillion inference per day on servers and more than 70 billion inference per day on mobile phones. PyTorch application industry has penetrated across many domains, from content understanding of language, vision, speech, to complex tasks of ranking recommendation, robotics, to high-precision tasks of medical cancer diagnosis, treatment, drug discovery, many variations of autonomous driving vehicles. And PyTorch built a vibrant community. As we can see from the implementation of archive paper covering both research and production, it constantly growing over the past years towards a dominant position. As GenAI is the most interesting topic in this summit, most of GenAI models are written in PyTorch. So we are actually going through a very interesting model development paradigm shift now. From before, where a lot of individual developers or institutions are spending lots of energies collecting, curating, cleaning up data, and train a particular model architecture from scratch, and then deploying into production, to now, you can easily customize your model using much less data. As you can see from this paradigm from bottom up, there are many foundation models already pre-trained, and the weights released based on public data available on internet. And then you can specialize those foundation models with your domain-specific knowledge, for example, for finance, legal, healthcare, and so on. With your company proprietary data, then you can further customize towards your company-specific product by building your moat. And further along, you can even provide a personalized model. For example, building avatars or AI assistant to make your product even more interesting. So we have a foundational shift right now because of GenAI in AI development. You still get the state-of-the-art models from research, but with much less data, you can start to customize and build interesting products and do product exploration much, much faster. One out of many product ideas you tried, get into full-scale production, and your production drive more data, pushes better model quality improvement, and you experiment and explore more product ideas. And this quick iteration cycle is new. As you can see, in AI developer cohort, we have a new growing product developer coming up, like many of you sitting in this hall right now. So Fireworks is created to accelerate product innovation building on top of GenAI by solving many of the challenges we heard from many of you. First of all, the challenge is there's a huge amount of dynamism of GenAI models. And there's a stark competition of many model providers constantly improving model qualities one after another. It is very concerning to many people. How do I manage this ever-changing AI landscape? And which model should I use and stick to? As you can see from the right-hand side of the diagram, with the increasing timeline, the intensity and velocity of model innovation accelerates. Second, business task is never simple. It usually is a complex business workflow that needs to be decomposed into one or multiple AI models. And which layer in this hierarchy do you interject? And there are many interesting business problems people coming to us and ask how to solve that. For example, I want to use natural language as the interface to retrieve precise information from my company internal documents, or precise information from my product catalog. Or I want to automate my construction workflow to minimize timeline and minimize cost. Or I want to create diagram charts at scale based on my data. This is a first-mile problem, and many people get slowed down not knowing where to start. More specifically, within each model family, usually there are different model sizes being provided from small, medium, large, sometimes to extra large. And you can choose to zero-shot access the base model, or prompt tuning to get better quality, or fine-tuning user data to get even better quality. For specific tasks, you can actually fine-tune an equivalent quality or better model with a smaller size. So which one would you choose? Of course, generative AI is expensive because it's computational and memory intensive. In the past 2 to 3 years, AI research has been pushing for bigger and bigger model size until Chinchilla law get established that there's an optimal token to parameter ratio about 20 to 1. But still, most people are using around 7 billion to 13 billion model parameters. And that's much more bigger than traditional machine learning algorithm, for example, of XGBoost. Many companies get slowed down or stuck because of the intensity of the computational cost and quickly run out of pre-planned hardware budget. So we think the competition in the GenAI model space is actually great because the product developers and machine learning engineers can ride a free wave of ever-rising model quality. There will not be one model provider dominating the whole space. There will be many of them keep advancing the quality altogether. Fireworks want to enable you to continuously testing and evaluating the best model to incorporate into a product. Yes, continuously, because the cadence of change here is extremely fast. Second, cost to serve. We love this because we have been driving cost to serve, price performance, and general performance optimization for PyTorch for many years at hyperscalers. We hyper-optimize the cost for fine-tuned models. Fireworks today offer at equivalent model size 5 times cheaper cost compared with OpenAI-based model, and 30 times cheaper cost compared with their fine-tuned models. That's a whopping cost reduction. We also quickly optimize latency for open source models, for example, a nascent one, that we deliver more than 10 times latency reduction based on the original implementation. This requires deep PyTorch runtime optimization and integration with the best kernel, as well as carefully crafted scheduling, orchestration, design, and optimization, all coming together. We also understand to accelerate your product exploration, you need to do a lot of concurrent parallel experiments at the same time. And oftentimes, with the increasing number of experiments, it increases your memory footprint as well. That means you have to pay more. We want to take away that concerns from you. As you can see, we can effectively control the memory footprint with increasing degree of experiments. That means with fixed budget, you can run a lot of more experiments at the same time, and your time to market will significantly be reduced. Tying all this together, Fireworks provide a rapid experiment and production platform. We give you free access to the state-of-the-art research. With your own data, you can use our pre-built fine-tuning and evaluation recipe. You can change it, adjust it, adapt it as you wish, run the fine-tuning on-prem or on cloud as you wish. And then your custom model will be deployed to our general AI inference service with minimal cost to serve. You can then focus on your product iteration and exploration. When you like your idea and want to grow it to full production scale, do that within the inference service without changing to anything else. Today, we build our inference service on top of GCP, AWS, and CoreWeave. We plan to expand our cloud provider partnership quickly down the road. Our API is fully compatible with OpenAI API and Lin Qiao, so if you don't need to change your code much to use our services. If you feel the challenges I just mentioned resonate with you, and also want to know more about Fireworks, find me after talk, and also find the awesome Fireworks AI team. We can give you a demo and give you more information about what we're building. Also, stay tuned for many more exciting announcements coming up soon. Thank you. Looking forward to seeing all of you.
Our next speaker is a pioneer in the field of computer vision. He was formerly the head of AI research at Facebook in Menlo Park and is a distinguished professor at UC Berkeley. In his talk, he's going to talk about the latest developments of modern AI applied to robotics. Please join me in welcoming Jitendra Malik to the stage.
Hello. So I want to talk to you about the sensory motor road to artificial intelligence. But first, we should know something about natural intelligence. And natural intelligence, to make sense of it, we should think of it in the light of evolution. So something like 540 million years ago, we had the first multicellular animals that could move about. And moving was great, because that means that you could get to food in different places. But to get to food, you needed to know where the food is, which meant you needed vision or some form of perception. And these two abilities go together. And there's this great line from Gibson: we see in order to move, and we move in order to see. And so if you think of the brain or the nervous system of a fly or a fish or a frog, it's basically this connection between perception, which could be vision, it could be hearing, to action. And action is moving about in this case. So if you zoom ahead to like 5 million years ago, which is when the first hominids split off from primates, you have this additional accomplishment, which is that we start to walk on 2 feet, which means that the hands are free to build tools, make tools, and then you get the advent of dexterous manipulation and planning and all the rest of it. And then the last big development is, of course, for modern humans, like 100,000 years ago or something, which is when we have language, which is uniquely human, and abstract thinking and symbolic behavior. But what's important to keep in mind is that most of the brain is devoted to perception and action and connecting the two. And if you think of the entire evolutionary history as being 24 hours of intelligence, language is in the last 2 or 3 minutes. That's all. It's very important, but it's only the last 2 and 3 minutes. And in this audience, I don't need to say much about language models, but they're incredible. And they can do I'll pick one line, they can pass the bar exam at 90th percentile. Incredible. So given such amazing accomplishments, what I want to connect you to is the fact that we have so much trouble on another side of AI, which is the robotic side of AI, or self-driving cars. I have been in this field for 40 years. We have had self-driving cars for 30 years. Cars which drove across Europe from Berlin to Paris and across America and so on. And there's been a lot of hype about self-driving cars, and we'll get them. We'll have the cars. But think of how hard it has been. And it's something which, so we can pass the law exam, which takes years, and something that a high school kid of 16 after 20 hours of training is good enough at, we are having trouble with this. I can make this problem even harder. So think about what a 12-year-old kid can do, right? A 12-year-old kid in a kitchen with knives and forks and ladles and so forth can do all these kinds of tasks. And no robot today can do all of these tasks. Okay? This is incredible. Something easy we can't do. And this is something that people in AI have known for a long time. It's a paradox, right? A law exam, the bar exam, which takes years of study, is hard. And cooking an omelette is supposed to be easy. But actually, it's the other way around. Moravec had this great line, which is that things like chess are easy. Language is easy. What's hard is what a one-year-old can do. And Steve Pinker has a beautiful line for this, which is that the hard problem, what we have learned from years of AI research is that the hard problems are easy and that the easy problems are hard. And, and then he goes on to say that the gardeners, receptionists, and cooks are secure in their jobs for the years to come. And why? So the question is why? And Moravec's argument was to do with reverse engineering, and it was in the era of designing AI. And there the question was, okay, what has emerged through hundreds of millions of years of evolution is much harder to sort of reverse engineer. I think actually the argument is slightly different. We know how AI has been achieved. It's largely been through deep learning applied to huge amounts of data. And the kind of data we have, what's the kind of data we have? We have huge amounts of data for language models. Why? Because everything is on the web, right? All the books are on the web. Wikipedia is on the web. Reddit forums are on the web. GitHub is on the web. This enables you to train these models. So all this data is available explicitly. Think of what's the data needed for sensory motor training. You need to know what images I take and what are all my muscle commands and what are my neural activations. Hey, that's pretty personal. I'm not uploading that on the web. Okay? We are not going to get all that data in huge amounts on the web. We could get parts of it. We might see what the images are, but we're not going to get all of this. And therefore, we will need new, clever ways of solving this problem. It will need AI. It will need learning. And I'm going to take you through a little bit of how we can do this. And I work a lot in robotics, and this is one of the robots that we trained in my group. And it's solving problems. Its foot was stuck against the rock, and it managed to go through. This robot, by the way, is blind. It has no vision. It's okay. And you see it walking downstairs. It's not even aware of the stairs, but it manages to stabilize. Here's another example, which is on loose mud pile and at a construction site. And so on and so forth. So you need a lot of versatility. So these problems are actually hard. And let me think of it more formally. Computer vision is like pattern recognition. And the basic challenge is generalization. So we can't have a formal definition of a chair, but we can train a classifier for chairs by giving lots of examples. When we come to these motor control tasks, it's a different game. One part of it is handled by classical control theory, which is robustness to disturbances. You do feedback control. There's a second part, which is actually the more interesting or harder part, which is that adaptation to these different conditions. So I showed you this setup where this robot dog has to walk in all these different terrains. So adaptation, that's very important. So we can use classical control theory techniques to train controllers for particular situations. And for example, Boston Dynamics has a lot of work demonstrating these kinds of controllers. But where AI and machine learning can come in is, can we build one policy to work in all of these situations? One policy which figures out automatically which situation you are in and then it walks in them. And this is work from my group called Rapid Motor Adaptation, where we figured out essentially how to do this. And I'll just take you through the big idea. So the big idea is we train this robot in simulation, and this base policy is like figuring out how to change all the joint angles and things like that. And there is this variable z, which you can see in that diagram, and this z captures some aspects of the terrain as some low-dimensional vector. And if we knew the z, we have this policy which will do different things. So it does different things in sand versus in hard ground and so on and so forth. OK, but how do we do that in the real world? We need a way to estimate that itself. And for that, we sort of need to go meta. So we have an adaptation module, which, looking at the past history, figures out how to what the z must be. So the intuition is something like this, that when I walk, if I walk on hard ground, I perform certain actions, and then there are consequences of those. If I do exactly the same thing when I'm on a beach, it's going to be different, because when I put my foot down and I try to lift it up, it's not going to lift up so easily. And that kind of signal from the state and actions over the past 1 second or half a second, I have this signal. And that's basically it. I mean, there are some details, obviously, but I'll show you an example here. So here is an experiment which my student Ashish did, where he's pouring olive oil and on this waste of good olive oil on a mattress. And then he's going to take the robot, and if you look at the legs of the robot, he's got like plastic socks to make it hard. And then he's going to make this robot walk. And what happens is that it starts to slip, right? Let's do it in slow-mo. So what's happening is that it has some estimate of the extrinsics, this z vector, and that estimate is wrong because it's slippery. Now what should happen is that over time, when it walks, it estimates this, and that's being done by this adaptation module. And once that estimate comes through, it works out, and then it's recovered. I'll give you another example. Now it's a much harder problem. I've got this robot which has got a vision system in it, and it's going to walk in much more treacherous terrain. So now there's a camera, and everything is on board. It has no advanced knowledge of the terrain. And it's using similar techniques. Notice that this robot is a very short robot compared to the heights of the stairs, and it's yet able to manage in these conditions, and it has no prior knowledge. And this is slippery ground as well as a slope. So, and these ideas apply to other applications besides walking. Thank you, thank you. And there's one which is dexterous manipulation. So if I want to cook in a kitchen, I need to be able to manipulate with my multi-fingered hands. And here's an example of that. Similar idea, estimate what the situation is. So in this case, there are objects of different size, different shape, different weights. And I mean, that's what this says. And these are being estimated online. And so, for example, the shuttlecock is very light. It's only 5 grams. Okay, and some of the objects are heavy. Okay, there's this empty bottle, a Rubik's Cube. Very importantly, it's exactly the same policy. The robot is blind. It has no prior knowledge of what it is trying to control, but only from the proprioception, what it feels in the fingers, it is able to do the right thing. And I have more examples here. So I think that this is the future. I think we have to, machine learning and AI is essential for the success of robotics because we need flexibility and we need adaptation. But I want to conclude in the last 2 minutes that I have with some general philosophical remarks. So I entered the field of AI 40 years ago. For me, the success in the last 5 years is incredible. I would never have thought we would have got so far in what we did in the last 5 years, where we were 5 years ago versus now. And broadly speaking, deep learning in the last 10 years. But how do we do the rest? I think robotics is very important. Sensory motor control is very important. Without that, we have not achieved intelligence. There are these ideas for this which go back to Alan Turing. Alan Turing, who's like the father of computer science in a way. And he has this paper from 1950, which has the Turing test, but it has this great line. Instead of trying to produce a program to simulate the adult mind, why not rather try to produce one which simulates the child's? So it's essentially a program of learning, but learning with stages the way children learn. And we know a lot from our psychologist colleagues about how children learn. Children go through various stages of learning. There's this multimodal stage. This kid in the crib, she's playing around, she's poking at objects. So she sees it, she hears the sound, she puts things in her mouth, her motor system is being activated. All of that is training data. All of that is being used. The kid does experiments. So Alison Gopnik has this book called The Scientist in the Crib. So when your toddler is being difficult and throwing food down, you should say, she's actually a scientist in the crib. She's conducting an experiment from which she is building models of the world around us. And this is very important. And then finally, this child, at the age of 2, you take them to the zoo, you give them one example of a zebra, it works. And our programs, we need to give them thousands of examples of zebras. And then at the age of 16, we give them 20 hours of training, and then they can drive, right? So I personally believe that this developmental story is going to be needed for all of AI. And the psychologists have actually told us what these steps are. Multimodal, incremental, physical, explore, be social, learn from others, and finally use language. So language is very important, but it is, in a way, the crowning achievement of intelligence, and it should be built on this substrate of physicality. Thank you very much for your attention.
Please welcome to the stage co-founder and Senior Vice President of Field Engineering, Arsalan Tavakoli.
Good morning, everybody. It is my distinct pleasure to help host this fireside chat today. We've clearly been spending a lot of time talking about AI. You know, where is it going? What's the future? How do we get here? What's next? And my guest this morning is somebody who has been living in that world for a very long time and needs very little introduction. Please give a warm round of applause to welcome the former CEO of Google, Eric Schmidt.
Hi, Arsalan.
How are you?
Hi, everybody. Good to see you.
Thanks for coming. I'll be honest, I've been at Databricks for 10 years now, and my parents were the most excited that this morning. They're like, they didn't care about anything else. You'll be on stage with Eric Schmidt. I was like, yes.
Well, you know, I was here before. I was here 30 years ago on this stage, and I introduced Java right here.
Well,
so
quite an accomplishment.
Do the math.
So there's obviously a lot of directions that we can go into. I'm pretty sure I'm going to get yelled at to get off stage before we can get through everything. But, you know, one of the topics that everybody's interested in is just the speed and fervor which things have come on the generative AI side. And you've been living in that world for a while now. So curious to just hear your perspective. Why now? What's led to this kind of interest and drive?
Well, what's the value of inventing a new kind of intelligence? Probably pretty high. What's the value of improving every single business process, communications process, entertainment process, educational process in the world? Pretty high. How big? I did a report for the US government which said it was a $40 trillion business. That's big enough to get everyone to play. And the other thing that's interesting is our industry, when I started, which was almost 50 years ago, we were not very good at talking about ourselves. We were actual nerds. We were not actually nerds with shine, if you will. And the industry has changed, and we've gotten really capable of hyping ourselves to the max, right? And I can give you the data of adoption. Look at the rate at which ChatGPT was adopted versus Gmail as a simple metric. But the fact of the matter is, it's both better hype, better excitement, and compression of time. One way to understand this is that before the internet existed, your company, you actually had to sell. You had to call on doors and send CDs and so forth and so on. And the internet created, at least for digital goods, an immediate instant success history, which is now what's driving this. There's this sense that you can go completely nonlinear with something successful. The other problem is that the compression of time means you have almost no time to get it right. And small differences in timing can have huge statistical outcomes based on when you started and when you got there, which is why everyone is in such a rush to get funded, to get people, and so forth. Everybody kind of understands, do it right now.
Okay. So there's a little bit of that. Now, it's very interesting. Somehow, you know, generative AI all of a sudden has become all about the model. Everybody talks about the model. And this big question, we get asked a ton about it from customers. It's been a topic where I think it's fair to say for many, generative AI became synonymous when ChatGPT and OpenAI came out. And so there's this debate. Is the world going towards this part where there'll just be a small handful of these large foundational models? Or is it going to be more towards whether it's open or specialized models? Is it a balance? We get asked a ton. Obviously, you know, I've seen you talk about it. How do you think about what the future is, the need of the different kind of types of models and how they'll be leveraged?
So about a month ago, a number of us wrote a blog post which tried to answer this question.
Yeah.
And the answer, of course, in tech is both. You're both going to see these incredibly powerful, very, very flexible, what we call frontier models, and they're going to get used in business processes, but you're also going to see incredibly powerful specialized models. Both will happen for different reasons. If you think about it as a business, so one of you is trying to build a company that uses advertising, but you have an idea to generate the ads for the customers instead of making the customers generate the ads. That's a good idea, and by the way, Google has just now announced they're going to do that. Good job. So you do that. Do you really want a fully functional, learning, changing, and so forth, powerful general purpose model? Or will you be better off served with a specialized model that does a better and better job? And I think in that case, you would want the latter. If the questions are more open-ended, you're probably going to want the more general model. Since we haven't proven the business models of either of these, right, we literally don't know exactly how they're going to get monetized yet, which, by the way, is a testament to the world's financial system, that we could raise billions of dollars without having a product plan, a revenue plan, a product price, and an identified customer. Thank God for the financial system. And, right, we're all here because of that. So I think you're going to see both. And one of the most interesting questions is the rate of diffusion from the frontier models to the open source models. So if you take a look, GPT-3 is now, the functionality is largely available in the equivalent of Alpaca. That's roughly 2 to 3 years in terms of diffusion, from a very expensive, very powerful model to something which is generally available and effectively free.
Yeah. And I think the question becomes, as we keep getting more and more powerful, at what point is it good enough, like for the different use cases?
Well, the correct answer is it's never good enough in software.
Yeah.
Right? We still, we have the M1, the M2, the M3, the M4. We have 5 nanometers, 3 nanometers, 2 nanometers. It's never good enough, but somehow we find a way to use up all of the software. It's the old rule, you all probably don't remember this. It was Grove giveth and Gates taketh away, right, was the saying. That Intel would add CPU, And Microsoft would immediately use all the hardware for the software that they were building on top. This was 30 years ago. It's still true.
Okay. So we were talking about this, briefly backstage. There's a lot about the models, and we spent talking about the specialized models and all of that. In this world, how do you think about the importance about things such as like data and governance and data quality in terms of driving improvements in effectiveness in the use cases around AI?
What's interesting is if you look across the fields that are using AI, people talk about the algorithms. So if you think about it, what do you need? You need hardware, you need scientists, you need programmers who can build scalable systems, which is not the same thing as scientists, and you need lots and lots of data. In many fields, the most interesting data is data that is being synthesized, right? So for example, if you have a physics model and you can the physics, because the physics, physicists are always right in my world, they can essentially simulate and therefore generate the data that's needed for training. Yeah. There are plenty of other examples where people will do essentially sampling of the data. So they'll, for example, sample a series of questions and answers, and then they will perturb and generalize those for training. All of these tell you that data is the key, and it's important that the data be curated. I wish that you could just sort of run these things over every piece of data, regardless of structure and so forth. And I think this is sort of why you guys founded Databricks, is you were trying to do this, right? And you've done it super well. So you're one of the components. You need to also be helping people hire the right technical people, get the hardware and so forth to make it complete.
Got it. And so in the role of that, you basically just touched upon it, of data. Right now, the other aspect you talk about, how important will human feedback be in looping that in order to basically make sure that the models are improving and AI is successful ultimately overall?
Well, RLHF is a really cool idea. When I first heard it, I figured it wouldn't work. But it turns out it works really, really well. And there are now new techniques which allow RLHF plus LoRa, basically quick adaptations of the model, which allow you to fine-tune using relatively standardized open source packages that are available on GitHub and so forth. So that has led to this enormous explosion of variance. And so the most likely scenario, in my opinion, we'll see, is you're going to get a pre-trained model that's quite good, a base model, and then you're going to see every conceivable combination in the pipeline, right? RLHF, various other things, synthetic data, synthetic training, evaluation, and so forth to get there. The next thing that happens after that is the ability for these models to call to some reference point, some ground truth source. And there are startups that are working on calling, when it gets confused, which they always do, calling out of the model into something to get a reference point and then put it back.
Okay. Maybe switching gears a little bit slightly from that, we've been talking a lot about the potential, the opportunities for AI. There's definitely a lot around there. I don't know if fear is the right word, but uncertainty of where it's going, and that kind of coincides with discussions about regulation and what's regulation going to be, how things are going. How do you see, do you see us broadly getting alignment on how to regulate AI and the path forward, or at least the challenges that are there, categorizing those and how we should be thinking about those going forward?
Well, it's interesting that every single politician that I speak with, every single leader I talk to, is now an expert in AI, and they know nothing about what you all are doing. So maybe that's always been true, but it's sort of alarming to me. And so the first thing I always tell them is, do you remember that movie where the robot gets out and then the female scientist slays the robot at the end of the movie? That's a movie, okay? We're not building killer robots yet, right? Yeah. And that usually sort of disarms them. So when you talk within the technical people within the industry, who are, I think, the only people who really understand what's going on, there's a consensus around 3 reasonably clear short-term threats that are important. The first one is the one around misinformation and disinformation, and we can talk a lot. Everyone understands what that is, and everyone understands it. Furthermore, generative AI is going to be used enormously for that kind of stuff, so we've got to talk about that. The second thing is the ability for these systems to do various forms of cyber attack, and the ability for these systems to do various forms of basically bio threats of one kind or another. And the consensus is that today, so first place, AI alignment is a term where how do we get these AI systems to follow human values? AI safety means what are the guardrails that we put on these systems? If you look, for example, at GPT-4, OpenAI spent about 6 months. They had a whole team who basically, using RLHF and other techniques, constrained the model.
Yeah.
And those constraints apply both at the API level as well as at their app level. So people kind of understand that model, and there's always this question of how do you test for safety issues that you don't know yet without deploying them? So there's a general fear that these systems, when they're launched, will not be fully tested because they'll have some emergent behavior that we have not yet seen, and therefore we can't test in. So that's problem number one. Problem number two is that because of synthetic biology and so forth, it's likely that these systems can accelerate at scale evil people. And so if you sit down with Google long enough and you understand enough about biology, you can probably get to a bad pathogen. These systems make that somewhat more likely. So we have to sort of think about that.
Yeah.
So the governments around the world all have variant approaches to this, but the simplest way to frame it is there are scenarios of extreme risk, and these systems are going to get regulated around extreme risk. I'm not talking about the things we always complain about, Johnny's dog ate, Susie's homework kind of thing. I'm talking about thousands and thousands of people harmed and killed from something.
Yeah. So, maybe one or two more questions for me because I know we'll run out of time. But it always happens. I don't want to call them kind of hype cycles, but whenever we get these technology, it seems like we go through transformational technology. There's some fear. There's some people who fear it. There's some people who believe that tomorrow, all of a sudden, we don't need programmers anymore because generative AI is going to take up. Neither of the two actually come to fruition. What's your sense of the timeline for when we will start seeing very, very meaningful, we're already seeing some of it, but like kind of almost crossing the chasm, meaningful adoption and leveraging of generative AI, like kind of across all enterprises and spaces?
So the first use of generative AI is already with us, which is programming. And the first and most obvious use is in enhancing the power of programmers. And this shouldn't surprise you, because every generation that I've been through, the technology was first used by its inventors to make them more productive.
Yep.
By the way, I'm old enough, this is what email was invented for, right? This is what we used Unix for way back when. We used it to make ourselves more productive. And I used to tell people inside the various companies that I ran that why don't you start by making yourselves happy, which is really hard, and then why don't you make your friends happy, and then come back to me, right? That sort of works. Mm-hmm. And we sort of forgot that. We decided that we could build arbitrary consumer products without actually using them ourselves, and that's a mistake. So I think the first use is programming. The gains in programming are profound, and it looks to me like half of programming can be, sort of think of it as a doubling of productivity, right? And that's going to continue. There's a whole bunch of startups that have even more sophisticated ideas around that. I think that's the first one. I think the second one is going to be in doing things which are in the normal course of business. As I earlier mentioned, this notion about advertising. Why do I have to design and argue through my tweet? Why can't the computer ask me what I want to talk about and generate a tweet that is guaranteed by its metrics to be the most viral, right? So if I'm trying as a marketeer to have the biggest impact, surely the computer working with me can help me make it happen.
Yeah.
So I think that all of these systems where the human is doing something that is against some goal that's administered by computers is probably the next one. It makes perfect sense to integrate that.
Makes sense.
Right. We know what virality is because this is what we do all day, whereas we do it 24 hours a day and you're sleeping.
Yeah.
So we'll tell you how to do it. And again, that's an improvement in efficiency, if not quality. And then the next things are these more specialized markets. We don't yet know what the value of intelligence is. We don't know how to price it, but it's obviously high.
Yeah. Okay. I like that set of categorization, and we see something similar in terms of the use cases people are adopting. Now, one of the big barriers right now as people think about, you know, LLMs and building them and using them has just been cost. Cost is a huge barrier. It's what, you know, the cost to train them, access to GPUs. There's no secrets why, you know, NVIDIA is now $1 trillion company. You know, I'm just curious, how do you think that barrier of cost, both for training, for inference, for access, for infrastructure, you know, and access to the models coming down over time to make them more accessible?
Well, it's interesting that the training cost is extremely high and going up by orders of magnitude. There are people who believe that the frontier models, which cost on the order of $100 million to train, plus or minus, will go to $1 billion to train one of these things. So that is a massive change from a software perspective. In my career, we've never seen that kind of price increase to do software, which is what they are. On the other hand, inference, that is the ability to actually answer the question, looks like it's going to become trivially expensive. In other words, incredibly inexpensive. And so you end up in a situation where you train one of these models, and your biggest problem is making sure it doesn't get stolen, right? You spent $1 billion for these weights, right, which can basically be put on the equivalent of a hard drive. You need to make sure they don't get stolen and used by your competitor or whatever. And so my guess is that right now you have NVIDIA leading. It's a sore point for me because at Google we had this whole TPU strategy, but 95% of the training is being done on NVIDIA A100s and now H100s. And NVIDIA has recently talked about a successor next year, which they cleverly call H100 Next, which sure looks like it's another acceleration in power. So what NVIDIA did particularly well is they worked on what is called the FP8 cluster, where basically it's 8-bit floating point multipliers very quickly. And they put a special module in that helped them. And now in the H100, they have an integrated memory architecture that's stronger. One way to understand that is that the way this training works is you have this very large amount of data that's larger than you can put on a computer. It's essentially in the network in the data center. And the algorithm is going back and forth and back and forth and back and forth for hundreds of millions of dollars. Anything you can do to decrease network latency, bring the memory closer, is a huge speed up. We're still in the phase where these computer architectures are evolving faster than I've ever seen. Much faster than Moore's Law, much faster than I saw CPU architectures, because of this unique nature of these LLM architectures. And that's going to continue for a couple more generations.
Okay. We're about out of time. One last question. You know, you've got tons of enterprises sitting in the audience here. If there was one key piece of advice you could give them of this is what you need to think about in order to be successful in harnessing the power of generative AI, what would that be?
Well, the small companies are run by people who are here because you understand that this is core to your business. So a simple rule for a small business is you're not going to be successful unless you use AI in your model. And a simple way of thinking of your business is you have an Android or an iPhone. By the way, Android is more popular than the iPhone, just for data. And you have a network, and then you have a server, typically in the cloud somewhere, which is using AI in your business. So think of it that way. You understand all of that. For larger corporations, and I talk to lots of the leaders of those, what I tell them is the following. You don't know what you're doing yet in this space. I say this in a nicer way. You don't know what you're doing in this space, and your team may not either. So give them the following assignment. For every business unit you have, come back and show me a prioritized list of what you can do with generative AI. All right, just show me the list, right, and get them all together. And most companies that have done this will come up with 400 or 500 ideas, some of which are customer service, some of which are revenue enhancing, some of which are security, right? And they'll come back, and then the CEO says, holy crap, right? Look at all this stuff that I should be doing. And then they realize they have no people to build it. And then they have a crisis.
Awesome. Well, Eric, I'm pretty sure I speak for everybody here. It says thank you so much for making the time for this. It was amazing to hear.
Congratulations to you guys, and congratulations for everybody.
Awesome.
Thank you. Thank you, Arsalan.
Thanks again, Eric. Appreciate it. Cheers.
Thank you.
Okay. So one last announcement for folks. This wraps up, basically today's day of keynotes, a bunch of really interesting breakouts. Save the date. Data and AI Summit, basically 2024, will be back here at Moscone, June 10th to 13th. As far as I know, we're the only conference scheduled that week. If that changes, don't look at me. It's not on us, right? Take care, everybody. Cheers.